Hello, welcome. Today, gonna stop arming. We're doing some more Phoxel development because I want to get this single color working, so that I can go back to making my voxel sim because that seems like much more fun. But I'm gonna get this rendering working first. Been spending the last half hour while I was waiting for the time of the stream to start, trying to work out exactly when Bevy like sets the mesh, which is weird. Like mesh pipeline. Red device. So it's gotta be in here. Reuse allocators. Model only. Some layout model only. Binding resource. Okay. Mesh paste bind. Okay. Create the skin mesh bind group. So binding resource and then weights. So mesh layout morph binding. See, what throws me is obviously this model is the model instance data binding, batch phase instance buffers, instance data binding returns binding of the buffer that contains the per instance data. Needs to be filled in via compute shader. Okay. This one. Okay. Returns the binding of the buffer that contains the per instance data. If we're in the GPU instance buffer builder mode, this buffer needs to be filled with via compute shader. Right. So that's this one. Interesting. Okay. Okay. So interesting. All right. So somewhere we fill this, which is you. Okay. Batched instance buffer. Okay, option. You wrote it differently, which is a bit weird. How did? This is the GPU. So CPU batch. All right, because you only have one. Right, batched instance builder. Mesh. Okay. I'm still unclear where this comes from. I just need to work out where exactly you collect render mesh instance to build up the uniform buffer. Well, obviously I don't care about that one. Right, got that. So first we have this. So use. So this is when we insert it. Okay. Batched instance builder. The GPU buffer holds the data needed to render batches. For example, in 3D PBR pipeline that holds mesh uniforms, which are the PB type parameter. In that mode. Okay. So is it saying I can't batch instance buffer? Now the question is also collect meshes for GPU building. That's obviously not correct. Create the render mesh instance GPU and mesh import uniforms when the GPU mesh uniforms are built. Okay, so it can't be that. Interesting. So that's inserting GPU number GPU, then this is working on GPU, and this is non-GPU. Prepare mesh bind groups takes in, and so the last two. So what I'm not following here is when exactly we build that. It's very confusing. So if GPU instances, okay, so it's probably here that's like if we're not, because I can't understand why you call a init but you don't. Because you don't need a bind group, I guess. Interesting. GPU array build buffer. The CPU batch instance buffer. Add system. Extract meshes for CPU building. Okay, and then non-GPU preprocessing write batch instance buffer. It's probably that one. Mesh pipeline. Fuck knows what that means. Okay, get batch data. Buffer data. Oh, okay, so that literally just writes it to the GPU, which is fine. We don't even remember where you were doing that. Wait, yeah. So prepare resources flush. Okay, so that's interesting. So it's got to be extract meshes from GPU and set. Extract meshes set. Okay, so extract meshes for CPU building. Does this take in render material instance? Render mesh instance. Okay, what I'm not following is how the theorem, wherever I was, that you, yeah. So when do you come into this? In as much as extract meshes for CPU. So we insert you, but then we just like never use you. So this is for GPU building, which is obviously not correct. So this is in there. Okay, prepare. This is preparing the bind groups, which obviously doesn't. Batch phase instance data. Instance data binding. It's what's throwing me. No GPU preprocessing. Okay, so options res. So when do we populate you though? Right, because we extract you. It's binding of the buffer that contains the per instance data. Okay. But question is, it's got to be one of these two. So we insert the resource, and we say add system, extract meshes from CPU, for CPU building. Random mesh instance. This is okay, and then this just writes it. So this literally does nothing. So this is like literally the only thing that can be populating it. Batch random mesh instance. Render material instance. It could be that this is coming from somewhere else. And mesh render. Okay. No, PBR render. So this is from here. See, because this is how it like stores it. Render mesh. Extended in the render. Okay, render material bindings. That's, I'm not following when exactly you populate the fucking the batched instance buffer. Like, it has a mesh map of main entity and then mesh rendering instance CPU. Render mesh instance shared. Render mesh instance shared. Transform mesh transforms. The translation of the mesh. This will be written into the mesh uniform at the appropriate time. Okay. Data share between the CPU mesh uniform building and the GPU mesh. But when do we populate this? I do not understand. Right? Because the only other place we fucking use it is here. And we don't actually use it, we just instance data building. Data binding. If let okay. Possibly you pass in so CPU batch instance buffer. And then if let some instance data binding. Okay, if this path we only have a single set of binding groups for all phases. Mesh phase bind groups. Mesh pipeline meshes. Just, it doesn't run it in here, right? Meshes. For ID GPU mesh. Bindless support. I don't know what the fuck's going on. Okay, so create the morph bind group just like we did in, okay, so we didn't create that, so mesh phase bind groups, model only, layout, model only, render device, model. Okay. But this just makes the bind groups, it doesn't bind the meshes. So what I'm struggling with here. Do we use groups? We use, okay, so group.skin equals this, okay. I'm pretty sure this just only sets other stuff. So that's not really gonna help. I still have no fucking idea when it's extracting this information and when it's setting it, so fuck knows what's going on. Right, so okay, so I do wonder if Because at the moment I'm not really doing anything, so we want to go like I think not shader, material. So let's bind group. So I think we're going to go something like uniform. No, not uniform. Texture? Image? I don't remember how to do this. I have completely forgotten. Sampler? No. Alright, so if we go to simple shader and we go, hey, how do we do this? So we say texture and then sampler and then pass in a handle like that. Interesting. I want to say that's how we do that. I don't know. So I can do that, and I can come to somewhere. Render. How the hell did I do this? So something set bind group. So I need your here, I guess your view query. The fuck? Okay, item query, pipeline cache. So it would be a like S resource, right? Because I'm pretty sure it was our mesh bind group thing that was doing it. Mesh bind groups. Then it's Betty's mesh bind groups. Now, it's getting more and more confusing. All right, so it was in here. We go here. Is it so batched instance buffer? Okay. I mean, I guess technically, solid. So we need solid batch binding. Yeah, bind group. Something like that. And then we need to make a new thing like struct solid batch bind group, and then it's yeah, bind group, which is in a bind group. Render resource bind group. Okay, something like that. Then you need to be a resource, derive resource. And then we need to go like fn extract solid bind group okay, something like that to do. Yeah. Print line to do. Okay, so then we're gonna go fn right solid bind group. Right, so that one is going to take in batch, and then it was this. Go to the res batched instant buffer. And its thing was like super shader, no, material solid color, right? I'm assuming. Let's qualify you so you don't blow this up. Render batching, no GPU processing, batched instance. Okay. All right, batch instance buffer. Nope. Okay, the tray. Okay, so it needs shader size. Okay. Okay. My question does become one of, what the fuck? Okay. So apparently as bind, I guess it's as bind group is different, isn't it? Okay. Batched instance buffer. So there was mesh uniforms. Okay. Which, okay, so the mesh, right. So I guess that means, can we just like comment this out for now? And then obviously make a second one. And the second one is just going to be exactly the same, but we're going to say, as, oh, shader size. I'm sure it says shader size. Maybe it should shader type. You say that it needs to be shader size. Bevy render is a shader size. Okay. Maybe it's it needs to be shader type. Shader type. Is there a difference between these two? Shader type. Base trait of all shader traits. Okay, so my question then becomes, does that implement shader size? Probably. Yeah, shader size is implemented for shader type non-zero, metadata min 0. Okay, so I'm assuming shader type just means that it can write. So the trait bound is not satisfied. Okay, so there's definitely a way of doing this. So we would want to say colors and then just make it an array of vec3 by 256. I don't know if that's gonna really work, but okay, kind of does. Interesting. Pipeline cache, something. You're complaining because we need to say batch. So then we need to say something like pipeline cache and then we say pass.set bind group, and for whatever reason I've decided to make this generic, so we're going to say set bind group I, and then the bind group, and then dynamic indexes is going to be like no, and then the bind group is batch dot bind group. Can I do that? Is that the reference to the bind group? So reference bind group. Then we need to say, okay, so this needs to be, success needs to come down here, and then we need to return early if we fail. Return skip. Okay, so batch may not live long enough. What? What do you mean batch may not live long enough? Ah, God damn it. WS batch original. Yes, declared there. Set bind group, wait, bind group, so A. Batch does not live long enough. Borrow value does not live long enough. How can I just clone them? Clone? How the hell did the mesh one work? Mesh set mesh bind group. How the hell did you work? Set bind group. There's my bind group. Where did you pull this from? Mesh phase bind group. Mesh bindings. Oh, I've got it into inner. Okay. Okay. Dot. So u dot into inner. I don't know if that'll work because that's a temporary value, but I think I have to like. Oh, nope, that works. Okay, so right, so pass set bind group, and then we call render 66. Okay, so next we need to like first off like make sure this is actually done properly. So how did this work? So this is I have to like work back my way to wherever the hell mesh was doing it. So somewhere one of these meshes. Okay, so render device. Wait, what do you use the render device for? Skins use uniform buffers. Attach the previous skin index for the motion. Okay, weird. So, better not be in here that you set the fucking meshes. It very much could be. Vertex buffer slice. Batch range. GPU mesh. Buffer info. Interesting. Wait. Okay. Draw either directly or indirectly as appropriate. Okay, I'm gonna assume that that doesn't like load the data. That'd be weird. Right. How, when, where? Okay. So it's mesh. Yep. Okay. It must be in here. Not set by new. Something. Batch. Yeah. Okay. Batch instance buffer. Wait. So they are actually called something different. Huh. Okay. So you had two things you did. Yeah, wrote, and I want to know when you write. Yeah. So yeah, so add system render set pair. Okay. So we need this, and then we need to say write batched instance buffers. Render device render cure matched instance buffer. Wait. What the hell is this get? No CPU processing. A trait to support getting data used for batch drawing commands via phase items. This is a simple version that only allows for sorting, not binning, as well as only CPU processing, not GPU processing for those fancy features. See get full batch data. Weird. Okay. So confused. Okay. So somewhere here, all it does, it just this is something like batch dot write buffer, and then we need access to render device and render queue. Render device and queue like that. And then I guess you need to be mute. You also need to be mute. And then we need to bring both of these in. Let's call you buffer. Okay, so okay, something's private now. Okay, so make you public. Okay, so we need to go up. I think it's in here. We build the app and we say, hey, render app, can we go down here and be like render app dot add system to render. We're going to call render render. Yep, we need to make that public, don't we? Add render. Right, so this is going to take in whatever the render app sub app. Okay. Mute. Mute sub app. Something like that. And then we say app dot add system. No, it looks like this. Oh, I just copied it. God damn it. Well, good thing I got a copy here. Like that. Render. Add render. No, no. Not render app. Render. Add render. You need to be public so that I can see it, and then we need to paste that in. So it's app. Okay, app add systems, and then we need to be like, hey, import render, and then it's right. What do I call it? Right solid buffer. Okay, so something like that. And then we grab the render set. Okay, so that should then write the render. Now, I've got one called extract render, right? So we need to be like dot add systems, and then it's gonna be something like extract systems and extract solid bind group dot after no dot inset, and that set is render set. Something about resource. Prepare resource. Phase buffers. No, bind group. Prepare bind groups. Okay. So how does mesh do it even? So we don't care about material right now. Or label main or render or pipeline mesh. So extract meshes for CPU building. Okay. Prepare resources flush. So this pulls them out of there. Okay. So I might just have like a default. Default. And we're gonna go here and we're gonna just, you know, drive default menu. Like that. Okay. Okay, we'll implement default then. Or can we just say that that colors? Okay, no, solid voxel colors. Yeah, do that. Except we want ones across the board. Everything will be white. Okay. So then that should be fine because then we can default that. Okay, so where's that render? So this writes our buffer, and this happens at the end of each thing. Does this have like? Please tell me this has checks that will be like, if self.temp.0 is empty, self.flush, self-uniform, right buffer. Okay. Right. So to prepare the bind group, render here. So extract solid. Okay. So we need fn prepare bind group. Right, so this is probably going to take in a mute. Bind group. Which is then a res mute solid batch bind group, and then something batched instance buffer. Don't know if you need to be mutable. We'll leave you mutable for now. So prepare bind group, and then it's just going to say so we need the render device as well, because I believe we need you to make a bind group. Okay, so I want to say that if we went like bind group dot bind group, what can I do with you? Dot ID? I don't think we care about your ID. See, the issue is that like I want to be able to check to see if it's changed, so we can be like batch dot binding clear filter into Asian push right try changed if batch dot is changed, then okay, render device create bind group. I don't think that's how you do that, but anyway. And this will return a bind group. Okay, so this is solid color voxel material bind group. Okay. So then we need a layout and our entries. Okay, so the layout is going to be, I think the pipeline has that. So I want to say like pipeline, solid color pipeline, right? And then it's bind group pipeline dot dot. Is it all private? So what I've done. Okay. Hub. Maybe. Okay. Dot. Okay. Voxel material layout. Okay. And then the final thing we need is our reference to our bind group entry. So a reference to an array, which is then bind group entry. So bind group. Can we just call batch dot binding? And if let some binding equals batch dot binding resource. Okay, so bind group entry did that actually bring that in? I probably did. Yep, okay. So you're binding 0 and the resource is binding. Oh, and let some. Is that how that works? Oh, so nice. So you don't need a middle, so we need to take away your mute. Res mute. Here is the resource. Okay. Oh wait. So that should then mean that our bind group is set up correctly, maybe? I don't know. See, I don't know if I can instantiate you without bind group. Which makes me wonder if I need to make this like a bind group, like an option. And if let some binding equals batch dot that, then that it's binding dot into, you know, it'll work now. Okay, so else return skip. Okay, so if we haven't bound it yet, it will skip it. Okay, so this is the prepare the bind group. So when we go to our thing, I say, hey, can we this is apparently an extract schedule. So this would be render, and then this would be prepare bind group, right? Something like this, because I assume the extract happens beforehand. So then we're going to go like dot add underscore system, and then we're like in the extract schedule. So extract solid bind group. So what do I need to do? So my first, no, I'm gonna stop saying so, Jesus Christ. Mute batch. Res mute. Solid batch bind group. No, it's whatever the hell this monstrosity is. Right, so do that. And then we say mute. Res mute. Now, I don't think this is the best idea. No, because each one's going to have the same. Well, technically it's not wrong. No, so we need to group them together when we do the batching. Anyway, so this should work. It's the fact that I'm using a batched instance buffer. I don't know what the batch data. Okay, so technically I'm not going to be using it for batch. That should be fine. So then can we say like batch dot clear and then batch dot push, and then we want to say here's default, something like this. Interesting. So we want to push a default one, and then we want to say like can we like let color equal no super material default, right, like this. And we're going to say we need to make you mute color dot set color 0 color hue saturation, linear RGB. I'm going to say 1 0 0, something like that, and then we're going to say batch push color. Right, so we need to first off add a set color function, but the idea here, simple solid set color, set color, so index and then color, and then color as linear RGBA F32 truncate. Is that like a thing that can actually be done? I don't think so. I don't think that exists. Yeah. Dot to linear RGBA dot vec3. Why are you truncating it? Absolute weirdo. Converts to a vec3. Linear RGBA returns. Okay, that should work, right? So that should then set our first a color 0 to red on the second instance, right? Which, to be honest, is slightly more confusing. When we say item, we get P, which is a phase item. But what the hell is a phase item? Okay, so we get our has a bin key which specifies which bin is placed in. Yes, but what is my phase item? Oh god, that needs to be size plus send plus sync. Okay, so I legitimately don't know what a phase item is. There's a whole bunch of stuff you can do with the phase item. Okay, so for now, we're not actually doing anything anyway, so I do kind of want to be like at startup, but so every single frame we're going to do that, and then if it's changed, we're going to do that. Okay, so first off, if we hit run, is it going to not crash? It's probably going to crash because we're going to try and set a bind group that's not in the bindings, maybe? I don't know. I think so. Because I don't know what we set you to. Your bind group, we're saying you're in binding position 0, and that your binding is the particular binding resource. So when we call binding on you, you're either a GPU array buffer uniform, batched uniform buffer, or you're a storage, which is a buffer vec. But how do you pick which one? You didn't like that, whatever it was. Batched instance buffer. Okay. Okay, so we need to instantiate it first. So We need to be like, I think it was something like let render something render device equal app.resource render device. Ooh, oh no. Wow, that's concerning. How did the mesh do it? Shade up map. One of these GPU array buffer. No, not pipeline mesh. How did you insert your theme lob? So somewhere GPU person. This is for GPU. How did you insert this? When did you insert this? So you're in render device world resource. Ah, okay. Wait, you resource render device. Okay, so it's app dot world dot render device. Okay, and then we can say let batch batch equal batching your buffer solid. Yeah, something like that. Like that. New render device, right? And then we insert resource batch. Right, so that should fix that crash. We also need to initialize. No, we don't, because we check to see if it exists. Which does mean. Wait, it's running buffers. This one I think won't ever run because the render device bind group. Okay, so I think we need to be like option like this, and we also need commands, something like this, and then we can go if bind group dot is sum no, if let sum mute bind group equals bind group. Then we do this. Right, wait this bit. Something like that, and then we go else command dot insert resource. No, not yet. Insert resource. You know what? I think it's smarter just to make this an option. Option bind group like this. Right. Then we can say u equals sum like that, and then we don't have to fuck around with doing all this weird like check and then magic. Because we're already checking to see if the resource is sum, so instead we're just going to say you're not an option anymore. We can also say you have default, since you can just be initiated with nothing. We need to dot init resource solid bind group like that. We go up here and we say, instead of saying binding into, so we're going to say that you're not an option anymore. It's batch dot into inner, so that it's the right lifespan, and then bind group, and then you just become bind group dot binding. Right, you just a reference to binding. The binding. Right. Cannot move shared reference. Okay. Let batch equal batch dot into inner. And then batch dot bind group. dot asref. And then we don't need the reference. Okay. So we prepare the bind group. Okay. So let's see if this works. It probably won't because, you know, my code, but we'll see. I'm trying to think what it's doing at the moment. So first of all, it's not like that. Okay. Request. Okay, right. Now, so you need to go. Well, where is Mesh doing this? Probably in Finish. Yep. Okay. So we need to go add render, and then we're gonna go like finish add render. Okay. Stop that. That, and then we say do this here. And then app dot insert resource that. Right. Then we have to go up a layout to mod, and we have to go, hey, when we get to finish, can we go to here and say pipeline finish add render, which we need to go make public. What is it is public? Not pipeline, render. Okay. Okay. Well, we at least got to somewhere. So I'm assuming handle fatal by default. Yeah. Valid areas and solid. Number of bindings in bind group descriptor 1 does not match the number of bindings defined in the bind group layout 0. Okay, so that should be easy because we go a pipeline, and we go, hey, pipeline. So first off, I think we bind you in position 3. Fine. So then we just need to work out when we initialize you, where do we solid color pipeline render device create voxel material. Okay. So bind group layout entry. So it's binding. This is binding 0, and then visibility, binding type, count. Okay. Is there a better way of doing this, please? Nope. Okay, so undo that, undo. Okay, so visibility. So visibility is a fragment, because I don't care about it being visible in the actual show. And then type, UI, binding type. Binding type is a storage. It's a buffer. All right. Okay. Something tells me that there's probably an easy way to make that though. Surely I can say buffer. No. Okay. Okay, so we have to go to like somewhere down here, and we say, hey, create bind group. Binding. Okay. So binding. So I'm still unclear. Okay, match self. GPU array buffer. Wait, so this is just a wrapper type then? No, it's just called on its inner self. Because it's deref, okay. So it's a GPU array buffer. Okay. So it's either a storage or, so when I say new, what the hell do you do? Limit device.limits. Okay, right. So maximum storage buffers per shader stage. There. Okay, so that's concerning because I mean, well, we render the pipeline second, right? So like it's here, like, so when we finish, we could like we could finish you, then initialize the pipeline, right? Okay, that's concerning. When the hell do we instantiate the pipeline? Because I feel like I should add the pipeline after. Something. Post update. There's a pipeline somewhere. Render up. Render up not found. Okay, init resource. Pipeline cache. Render command. Is it do I like do some weird chaining in terms of like solid color pipeline ID pipeline? Oh, look at that. We do. We create the pipeline and insert it here. Okay, which does mean that I can do that, which means that I can, in fact, request interesting. Let binding type equal world dot resource is it bind group? No, it was color something. I forgot what I called it. What did I call it? Solid batch bind group. No, it's not. It's batched index buffer. Okay, I really need to just declare this type. I still don't know what it's doing, so I don't know why I don't just make my own. Like I feel like I'm trying to use something that Bevy is doing, but in like a stupid way. Yeah, I probably should just make my own batched instant buffer. Okay, so when we go back to pipeline, why don't we construct our own? So obstruct batch data. Not even batch data is what's kind of stupid about this. So then it becomes a hub GPU array buffer that holds, yep, like that. Now I think I want you to be, oops, can I derive deref and deref mute on you, and also resource. And if I take this away, curiosity, yes, okay. So first off, bash data, okay, thank you. Capital of God, bash data, okay. Bash data, okay. So with that, we've magically replaced everything with with our special batch data. All right, so super render bash data, right, dot so write buffer and the type, no, okay, as returns the T shader type for self, where when used in as bind group derives, it is safe to assume all images in self exist. Okay. So world resource bash data. Okay, dot binding dot right, so for now I'm going to say unwrap dot type. No. So my question here, how the hell am I supposed to know what type this binding is? Right. Like, obviously I know it's a buffer. Wait, it doesn't have to be a buffer. Sampler, buffer, it's texture. Oh, I mean, it's going to be a buffer. And then the type is a buffer binding type. Okay, so it's either a uniform or a storage. Okay, and then there was definitely a fucking shortcut to do this, but what about if I said GPU array buffer? Can I do that? I don't think I can, because I'm assuming that if I said GPU array buffer binding layout render device. Interesting. So the issue is that you give me a bind group layout entry builder dot into finish build build binding. Oh, okay. So first off, this goes away now. Look at that. Okay, so binding 0, default visibility something shader stage fragment, something like that. Pipe annotation, yes, because you are a color, yeah, like that. Hey, okay, so then we don't need this, right? I feel like that should work, because then we're going to store the right thing in there, and then we're going to go, hey. I mean, I probably should have made it, wait, no, we should access it in fragment, because we're only using it for color. Doing it as an image would be a much smarter way of doing it, but, you know, I don't even know how to store the right data on the thing, let alone the rest stuff. Okay, bash data failed. Okay, right, because we didn't do it properly, because we changed how it works. So what did you do? I think you literally just create, yeah, you just call GPU array. No. All right, so if we go to and we say, hey, can we be like batch data? No. Okay. I don't know why I'm calling it bash data anyway. But, you know, bash data. Cool. So that should at least make sure that the resource exists in the first place. Yeah. Hey, okay. So I don't know what all those pipelines not ready were about. Probably me printing something that I'm probably not supposed to be printing. So now if we were to say modify the shader, we'll have to still rerun the game, but you know. So we modify the shader. So at the moment we're doing this, and then we're doing this, and so we're going, hey, at the moment I don't think we're even bringing in. So we're gonna go something like group 2 at binding 0. I don't think it's var uniform. It's like var storage. No, it would be a uniform. Would it be a uniform? Yeah, I feel like this isn't the best way of doing this anyway. Yeah. read. And it equal nothing. No, it's like this, right? So it's so okay, so it's a variable, storage read, and its name is colors, and it is an array of vec3 like so. Maybe the issue is that I think it's actually an array of vec3s, so it's more like array vec3 comma 256, something like this. I don't think that's how that's supposed to work, but anyway. Okay, so the question then becomes, if I rerun this, does it work? Or does it crash? Who knows? See, because the other issue with that is we're going to now need to somehow fragment. All right. So down here, after we like ignore everything, we're going to say let colors equals colors. No. So we're going to say 0, and then we're going to say let color equal colors 0. Right. I don't know if it lets me shadow like that. Okay, and then you become color in 1. Right. So let's rerun that and go, hey, any chance that this is going to render the cube white? Okay, promising, but it may just be rendering lots of 1s. If I change the colors to 1, it should set the color to red, because I'm okay, working. okay, so here's the thing though. I don't think during our render, but maybe we can, maybe like that's kind of half the point, is that can we write data at this point? I don't think so. Right. I don't think there's any way in here to write data to the pipeline. So P. There you go. So I do. All right. So first off, let's look at render command and go, what else do we have access to? Nothing. So we can only render. So I'm curious if we can at all pass any kind of data. So obviously, like, can we like pass dot? So we can draw something. We can draw indexed. We can draw insert debug marker. Okay. Okay. Multiple draw indexed indirect, multi in pop debug group. Subsequent rendering commands and debug markers are not grouped anymore in this group, but in the previous one, if any in the default top layer 1, if debug group has been the last one on the stack. Note that push debug group and pop debug group must always be called in pairs. This is a GPU debug feature, which has no push set bind group. Set blend constant sets the blend color as used by some of the blend model. Subsequent blend tests will test against this value. Okay. Wait, what? Okay. I'm curious. what this actually does. Self. Okay. Yes. Okay. But like self dot parse. What are we inside? Track render pass. Okay, and then set. So okay. Dispatch rendered. Okay, set viewpoint. And this must be a common trait. Render pass. Interesting. So like weirdly you can like change the size of the camera while you're in a pass, but anyway. Pass dot set rend. So we can set the pipeline. Stencil set viewport returns the render pass function tracking state some redundant. Okay, so interesting. But is there any way to like? Not really. So I'm assuming we would have to take over the draw mesh, because draw mesh I also do wonder if like changing the pipeline breaks things. Like, can I change the pipeline after setting? So anyway, but when we call draw mesh, if we're using the GPU processor, then we are compute shader having been run, which is of course only happens if it's completed. Otherwise, our mesh instance data won't be present. Okay. So pass.set vertex buffer. Vertex buffer slot index batch range. Okay. Draw either directly or indirectly as appropriate. If we run into we're in indirect mode, we can additionally multi-draw. We can't multi-draw in direct mode because WGPU doesn't expose the functionality. Okay, so render mesh buffer info index format count. Okay, not indexed. Mesh asset. Set index buffer. Parse item extra index none. Dynamic offset. Pass.draw indexed. Oh. Okay. So does that mean the index not indexed? Multi-draw indirect. Okay. So batch range. You're just a renderer here. Okay. The range of instances that the batch covers.
After doing a batch draw, batch range length phase items will be skipped. This design is to avoid having to restructure the render phase unnecessary. Oh, okay. So look up the indirect batch. Okay. Indirect buffer. Indirect parameters buffer. Indirect parameters offset. Calculate the location of the indirect parameters within the buffer. Where the fuck is this indirect parameters range coming from? Range. Okay. Times. Start times size of vertex count, instance count, base vertex, first instance. Non-indexed measures. Okay. Batch set index. Okay, multi-draw indirect count. Active vertex buffer based on the contents of the indirect buffer. The count buffer is read to determine how many draws to issue. The indirect buffer must be long enough to account for max count draws. However, only count elements will be read. Okay. Where count is the value read from count buffer capped at max count. Okay. The active vertex buffer can be set with set vertex buffer. Indirect buffer should contain count tightly packed elements of the following structure. Number of vertices to draw, number of instances to draw, the index of the first vertex to draw. Okay. The instance ID of the first instance to draw has to be 0 unless okay. The issue is I don't think I can pass any data in because I already have the buffer in, which isn't going to be too bad because what it translates to is that I just need to make a second buffer and do an indirect. So the idea being that at the moment, where'd my shader go? In here. So at the moment we're passing in an array, and arrays. And so what we could also do is pass in an array of instance IDs, because then we can use the instance ID to look up the index into the colors array. So it's like the instance 10 is array, like I want to use color array this. The other option is also just to bind each color as we go. I'm starting to think that might be the smarter option here. But then again, I'm not entirely sure, because like obviously I set the bind group, but then where would I do that? So, because I'm thinking like, why would you bother doing this weird indirect and loading like way more memory onto the CPU and GPU than necessary, especially considering that 99.9% of the time the colors aren't going to change, so this would be like 2 steps of indirection for literally nothing. Like in terms of most of the time it's just going to say 0 because it's going to be the 0th indexed. So my thinking is we want to turn this back from an array of arrays to just an array like this, and then we want to set the appropriate bind group. We want to bind the appropriate thing to 0. So yeah, colors. Okay, so it's just going to be that color is equal to color 0. So we have to go back to our test thing, and we just spawn like a second one somehow. No. Okay, so let's spawn a second one, but this second one is going to use solid colors add. So you're going to say colors equals, okay, then we colors set 0, so green, and then we're going to parse that to you, right? And then we're going to go you need to be -1y and then like 1z, so it's not on top of the other one. So this one will be white, this one will be green. Okay, that should work fine. And then we need to go, we're not actually extracting this anyway. We're pulling like real dodgy witchcraft on this one. So somehow, I don't entirely know how it extracts the asset ID. So somewhere extract mark mesh as changed if material changed. Okay. Check entity specialization. And then so then the entity needs specialization. Where do we use this entity needs specialization? Entity needs specialization, and I'm pretty sure you use holder vector of entities. Somewhere we use this entity needs specialization. Okay, extract entities needing specialization, but where do I put them? Okay. Entity specialization tick. What is an entity specialization tick? I don't know what any of this does. Okay. So remove main entity. Where are we getting main entity from? From entity. Okay. View. All view in view. Cache view. Okay. Specialized material pipeline cache. Specialized hash map. Retained view entity. Specialized material pipeline view cache M. Where M is a material? No, where M is just M. Solid color vertex. Okay. So my question here is, what the hell is this cache? Cached render pipeline ID. Okay. So it just returns the tick that it was specialized and the pipeline that it was stuck to. Okay. Useful, but not quite there yet. We'll get there. Okay, so it's not this extract entities need specialization. It's the Q material meshes. Okay, now this draws everything. Specialized material meshes? This is apparently yelling at me for all sorts of reasons. So this queues them. So I'm pretty sure this is just like what makes them say that they should be rendered. Whereas this feels like specialized meshes, which should be views, insert. So somewhere I've got something commented out. Material instance. render material instances. Instance get visible entity. So something tells me that when we extract an entity, we should probably be storing a instance. So okay. I also feel like we should almost certainly be using a texture and not a like a 1D texture and not an array, but we will get to that optimization when I get the thing working. So what we're going to do is we're going to make a pub struct entity color map entity material, something like this, and then this is just going to have map an entity hash map. Okay, something like this, and then it's going to say render mesh instances. So what was there was like a render resource or something? Render asset ID. Okay, render assets. So stores all GPU render assets of source asset as long as they exist. Asset ID. A as render asset as source asset A. Okay. So render asset here, and then it so uses an asset ID. Okay. So would mean that you map to an asset ID. Asset ID. Something like that. I need to accept one argument. Solid color voxels. Okay. So, okay, specialized meshes. No, it's extract entities. Extract entities need specialization. Check entities need specialization. This happens in the main world, and then this one extracts into the render world. So extract removed component. Okay, so specialized pipeline extract. So when I call specialized material meshes, oh god, this is horrendous. So this is render assets. So I reckon this render material instance, I think this, so how do we get this mesh? Render assets, okay, mesh, right. So I reckon this mesh instances is probably what gets populated with, the information that we need. Okay. So extract entities need specialization. Right, so then we need to go extract entity material, something like that, and then we got to go new entities. So this is going to be an extract, and it's going to be a query for entity vertex material. No, well, yeah, no, that's correct. Voxel material, like that. So then we need new what is it? I guess is it removed? Removed, like this. And then we go removed component, voxel material. And then we need to say, yep, get the map. Entity material map. We probably need to derive resource on you. Derive resource, and also, I guess default. Right. So then we go for entity in removed, iter remove. Okay. So this is remove any entity that, that's not how that's spelled. Remove any entity that has lost its material last frame. And then add any new or changed entity. This is first since you could remove and add in the same frame. Something like that. Okay. For entity in removed iter. I think it's read, isn't it? Yeah, read. Okay, so we remove them all, and then we say, hey, an entity and material. You don't seem to know what this is. I don't think I can do that because we can find out. Oh, so this doesn't need to be mutable. Why do you always make things mutable, you weird little entity dot. Yeah, see, okay, that doesn't work on extract. Entity material map insert ID. Why would you on weak then? Okay. So material. Right, so we have to go to the voxel material and go, hey, okay. Just do that then. As asset ID. Okay. No. Okay, not found in the current scope. So let's say fuck you. We're gonna go import. Actually, just can we derive deref? That should work. I think maybe. I don't know. Extract. ID. That should work, right? Mm-hmm. So you need to be mutable because you actually consume it. I assume. Right. So we need to work out where our extract system is being done. So I think probably just up here, which is part of the reason we need to probably work this out a little bit better. Okay, so somewhere, let's just tack it on at the bottom. Render app dot add system extract schedule. Nope, not extract schedule. And then it's extract extract entity material dot inset. Okay, I'm gonna move this in here because this is gonna get dumb if I keep doing this. So we're gonna say I don't know if it's plugin. FM add extract. Okay, we'll just take in app, like new app. And then we just say something like if let render app equals get sub app render app. Sure. And then we're gonna get else error render app not find cannot add Phoxel solid color extract systems. Is that not how this works? Oh, yeah, okay. So then we say like add this extract, and then we say, hey, nope, it's extract entity material, extract entity material. Add, dot after, no, it's dot inset, then render set. So extract commands, no. Extract, no. Prepare. So I don't know what. First off, the system set for the default app render schedule. Default app rendering schedule. This can be useful for ordering, but you almost never want to add your systems to these. These can be useful for ordering, but you almost never want to add your systems to these sets. Okay. That's concerning. Q meshes, Q render. So prepare. I don't know how I feel about that one. Okay, so a subset within prepare for initializing buffers, textures, uniforms. So let's just go here and be like, can I read all of these? So prepare render resources for from extracted data for the CPU based on their sorted order. Create bind groups that depend on these data. A subset within prepare for initializing buffers, textures, uniforms for use in bind groups. Okay, prepare resource collect phase buffers after. Okay, flush buffers after, but before render set. Prepare bind groups. Okay, render cleanup, post cleanup. Okay. So extract commands. This is used for applying the commands from extract schedule. Okay. Prepare assets. Prepare assets that have been created, modified, removed this frame. Okay, well, prepare assets is where it goes. Okay. So first off, we need to go. Hey, God damn it! Stop moving. Render app. No. Extract. It'd be app.add plugins. Extract. That's probably private. God damn it. I don't think you actually do anything, so it doesn't matter. What? Extract plugin. Like that. No. Extract plugin. There. Right. So we add the extract plugin, and then in the extract plugin we say, hey, can we add a system to extract materials? Okay. So then that should give us a mapping between. I guess we need to put a filter, and we need to say changed. But that's it. Very complex type, yeah. Allow Quippy. Very. What are you complaining about? Where did it? I'm sure it says somewhere Clippy master index. Yeah, but how do I make you shut up? Allow. Okay. Now Clippy's gone away. Right. So we say, hey, if it's changed, do this. Right. Okay. So because changed also catches added, I believe. So what am I doing? I am removing an entity. Okay, so we extract. Now there was a reason I was extracting, and I think it's because check entity needs specialization. Check entities need specialization. Right, we need an hub or extract color material. Right. So we need to materials. World assets. Whereas asset, well, I want to say is it res assets or is it extract? Not extend, extract res assets, solid materials. So that should be all the world assets, and then we say render assets. And then we go res render assets. Right. And then we need to also, maybe for the sake of for the sake of keeping things compact, I don't know, maybe extract used assets, and then we go res what did I call it? It was something like entity material map, like that. Right, so we're going to import entity material. We're going to go fn so unique, and this is going to return, I guess, a hash. I was going to return an importer. Scene self values cloned filter scene. Right, that works. Why are you complaining? Something is probably that the type is wrong, because we need to go like std. Maybe Bevy platform collections hash set. Nope, doesn't like that. Type annotation needed. I don't know. That work? Not really. Bevy platform. Okay, so can we say like std collections hash set? Okay. First off, get rid of the goddamn hashy thing. Something. It's probably no. It's because we want to say new. New. Okay. Bevy platform. Because if you say default, it doesn't know what type you're talking about. When you say new, it does. Okay. I'm baffled that fucking works. Because it's moved. Okay, it captures it. Cool. That's nice though. So expected material. Okay, so why are you saying this? So the trait bound render asset is not satisfied the following. Okay, so we have to somehow implement render asset for you. I don't know how to do that, but I will endeavor to do that. But the idea is that we then go for ID in unique. If render asset contains continue, if let some get well, else wait, one missing asset for ID. No method name insert. Unstruct. Okay. Render assets dot. Interesting. So something tells me that that means that the render assets are going to have some kind of fancy. No, I know it has an insert. It just doesn't have an insert because you don't implement render asset. So can I implement render asset or solid color voxels? Interesting. Okay. Describes how an asset gets extracted and prepared for rendering. In the extract schedule step, the render asset source asset is transferred from the main world into the render world. After that, in the prepare asset step, the extracted asset is transferred into a GPU representation of type render asset. Okay. Interesting. So can I get you to like implement visiting members? So source asset. Well, self. Self, maybe? I don't know. Okay, then type parameters is probably nil. Okay, so source asset comes in, asset ID comes in, and then parameters comes in, and the result is self or prepare asset error. Retry next update as bind group error. So can I just return okay self? Lowercase self? Source asset. Source asset. Interesting. So what I don't quite understand is you say that you are then into a GPU representation of type render asset. Does that mean that render asset has a restriction of being send sync static sized? Nope. I do not quite understand. Describes how an asset gets extracted and prepared for rendering. In the extract schedule step, the render asset source asset is transferred from the main world. So the render asset, which is this asset, source asset, is transferred from the main world into the render world. Okay. After that, the prepare asset step is extracted asset is transferred. Okay. After the prepare assets step is the extracted asset is transformed into the GPU representation of the type render asset. So you take in the source asset and you return self. Right. So my assumption is that self, for some reason, it doesn't seem to care, but I feel like you're going to tell me that trying to think. My assumption is that you need to be an asset type or something. Hence, like it saying that it will pull the asset out of the main world, turn it into this asset type. Render asset plugin. This plugin extracts the changed assets from the app world into the render world and prepares them for the GPU. This can they can then be accessed from the render asset resource. Therefore, it sets up the extract schedule and step for the specified render asset. The after generic parameter can be used to specify that A should not run until prepare assets after has completed. Okay, this allows the prepare assets function to depend on another prepared asset. For example, mesh prepare asset relies on the GPU image. or morph targets. So the plugin is created as GPU image. Right. Okay. Interesting. Extracted assets. Render assets. Prepare next frame assets. Extract render assets. Prepare assets. After register system. Get sub app mute. Okay. Cached extract. Okay. So I do have questions. So my bigger question is, it keeps telling me that it prepares it for the GPU, but what the fuck does that actually mean? Considering at no point does it seem to have any kind of requirement that it's even GPU compatible. Stores all GPU representations of render asset, source asset, as long as they exist. Render asset. But like, that's all your requirement is that a render asset. And render asset doesn't seem to have any goddamn restrictions on it. So I don't know how exactly you're able to store that on the GPU, but okay, whatever. So instead of doing this, we're going to say app.add plugins, render asset plugin for solid color voxels default. Something like that. So what did you do? You basically create a cache of some description. You you create the resources, extracted assets. So source asset. So handle assets. Okay. Render removed added. Okay. So then render asset. I just want to see how you do this, to be honest. So main world render resource scope cached state. I don't know what this state holds, but anyway, awesome event stuff. Okay, so events assets needs extracting, removed, modified. For event in events.read, added, modified, removed. We don't care that the asset was removed from assets T in the main world, as asset is only removed from render world when the last handle is dropped. Unused. Needs extracting. Remove, modified, removed. And then removed. Load with dependencies. Handle this. Handle this. Oh no. Extract assets. And then add, and then okay. Now let's go cached state. State and then apply. Okay. So this should extract them into the render world. We still need this because this is actually what like maps the entities to the handles and whatnot. Cool. So I'm just going to leave the Bevy code there and see what happens, because that seems reasonable. So this should extract all this data. Then somewhere we do some kind of weird like Q material meshes. So something tells me opaque phase vacation. So where was the bit that where they were doing? So this is just queuing stuff. This does nothing. It's gonna be the specialization, I think. Mesh. Mark mesh has changed. No. Okay. Q mesh. Q material meshes. No. So this is just what tells it to render. Now, interestingly, batch set key. Opaque 3D batch set key. Okay. My concern is that I have no way of setting what this key is. I do, because it's not. Well, you taking this. Mesh instance should batch. Yes. Okay. So somehow current uniform index. The index of the mesh input uniform in the GPU buffer. So I don't think I get to set what this batch key is. Like, this is just set by the fact that we're using the opaque. Something. Is it the pipeline? No, it'd be the render pipeline key. Specialized render pipeline with a key. But that's when we call specialize. So see, the thing with this is we need to go back to like material. Not this material, but we need to go like somewhere, maybe extract, because there's just a plugin at the bottom here. We can be like, hey, where is the material plugin? Okay, so with this material plugin, we can go here and I'm go like, pretty sure that this is what takes care of doing the thing. So entities need specialization, and then render asset plugin. This is basically what I was copying to come up with this. So what we need to do, look, render asset plugin, prepared material. Interesting. Material binding ID. Material properties. Interesting. I'm super curious how you work render asset. So apparently, like a lot of weird stuff. Prepare asset. Oh god. Raw material M. Render method. Mesh pipeline key bits. Okay, so mesh material, unprepared bind group material, and unprepared bind group returns a vector of binding index owned binding resource. In cases where owned binding resource is not available as for bindless texture array currently, and implementation may return as bind group error current bind group directory with the function. So pipeline, material pipeline dot material layout, render device, material parameters. I don't know where you got material parameters from. This is okay. So M as bind group parameters. Interesting. M param. Okay. Sure, I'll leave that for you then. So you pass in the material parameters and then force no bind is false. So unprepared. Let material binding ID match entry. Material ID.int. Render material bindings. Right. So it does do what I think it's doing. Okay, so then it does all this, and then it makes a binding for each material. Okay. I think. Okay. So I think we need to make a new module. This is all getting very, very weird. Mod bind groups. Okay, so we're gonna go pub struct material bind group. Okay, so I think it was you. No, this is my material. I really need to just like save this, close all of these. Sure, save that. I don't know what I changed, but anyway. So I need to not force things open. So I'm gonna go to you and go down to. Okay, I guess we could just open the material from anywhere. We need to go to material bind groups. Okay, force that one open, and then we're gonna go. FN, I don't know. Just so that I can use the IntelliSense, so we're going to go material plugin. So then we're going to go qualify this and then F12 this. Okay, so you had some kind of bind groupy weirdness. Strike schedule. So this is in the render app. Specialized material pipeline. Okay. Specialized mesh pipeline. Material pipeline. Mesh pipe time. Material layout. Bind group layout. That's okay, so it's not. What was I poking around in that I found it? So we have a material binding ID. Must have been down here. Oh, it's here. Which is a render material bindings. Hash map. Untyped material binding ID. Which is a material binding group index and slot. Within the slabs, what are these slabs that they speak of? Okay, so that there, which is the 2, 4, 5, 2, 4, yeah, 2, 4, 5. Render material bindings. Wait, what? Right, but yeah, okay. A resource that maps each untyped material ID to its binding. The duplicate information in render asset. This duplicates information in render assets, but it doesn't have the M type parameter, so it can be used in untyped contexts, like collect meshes for GPU building. Okay, so does that mean that maybe I don't need to be building this? Somewhere you stick in a render asset, and then with an A, right? So maybe it's not doing what I think it's doing in there. Okay, don't need either of you open. This, yeah. So then this does this, and then this render plugin. No, it's not. No, you prepare material. I want to know what this fucking slab's about. Okay, so fifth one. So all you are is just a look at a hash map. So hence the entry, and then entry occupied entry. That is a weird way of doing that. Aren't you just a hash map? Strange. Okay. To do, have a fast path that doesn't require recreating the bind group if only a buffer contains changes. For now, we just delete and recreate the bind group. Okay. Bind group allocator. Free. Occupied entity. Occupied entry. Dot get. Okay. Next binding allocator. Allocate unprepared. Unprepared. Okay. And then pipeline material layout. Okay. Occupied entry get new. Okay. And then otherwise vacant entry. Well, don't do that. Damn it. Okay, and then send in a new binding. Right, and then you do the same thing, but allocate unprepared pipeline material. So you pass in the pipeline and then pipeline, and this is layout and unprepared. So vacant entry dot insert. Okay. So we have to work out how the bind group allocator works, but that's fine. Material unprepared bind group. So, okay, and then there's an error. Retry next update. Okay, as bind group error, create bind group. This material has opted out of automatic bind group creation and is requesting a full custom bind group, invoking as bind group as requested, and store the result bind group in the slot. What? Okay. So material as bind group. Okay. Prepared, but okay, I'll get prepared. Random material. Findings insert material ID. Material binding. Other. As bind group error. Other. Other. Let some material binding ID else return. Okay, so if it doesn't remove it, return, and then free. Okay, so what the hell is this bind group allocator? Material bind group allocator. That's the real question, isn't it? My assumption is that it sort of stacks everything together. Material bind group allocator. A resource that places materials into bind groups and tracks their resources. Internally, Bevy has separate allocators for bindless and non-bindless materials. This resource provides a common interface that specifies to the specified allocator in use. Okay. But like, is it more efficient? The slabs, each of which contains a bind group. Not bindless. Okay, mapping from material bind group index to bind group allocated in each slot. Okay, the bind group that are dirtier need to be prepared. Okay, a list of free bind group indices. Okay. And so you need to be material, which is annoying. And you also need to be material. But why do they need to be material? Probably because it calls some function. Right. A single binding that is currently managing. An unprepared bind group. The allocator prepares all outstanding unprepared bind groups when these buffers are only referenced by bind groups. Okay. Okay. So by the sounds of things, why need to just be like which is yeah, like a vector of bind group. Sure. There you go. You can go away. I'm not using it. Interesting. Stupid. So somehow, some way, so how exactly do they pass this in? It's not like the pipeline ID. Draw function. Okay, correct material. How exactly? How exactly? Maybe we go. No, it's gonna end up here. So I need to work out where exactly. You? Okay, material plugin. Render as plugin post. Somewhere there's like a add render command. Add render command. Draw material. Draw material. Set item pipeline. Set bind group. Set material bind group. Okay. So you. How do you materials? Material instance. Material bind group allocator. Material instance. Okay. So you did some kind of weird material instance. Material bind group allocator, or wherever the fuck you are. Why did everything have like a weird bindless index table? Samplers textures. What? Bindless descriptor. The maximum number of resources that can be stored in a slab that corresponds to slab capacity in the bindless slab capacity attribute when as bind group. What? Okay. Material bindless slab. I legitimately have no fucking idea. well, we probably want to stick with the binded ones because I don't know how to do bindless. Okay. Bindless, no. Material bindless, non-bindless. Okay. Unprepared bind group. Bindings, binding resources, data, T. Bind group layout. Okay. So I feel like you do some kind of weird magic voodoo. Interesting. Okay, so okay, so you have some kind of weird material bind group thing going on. Now, the question becomes that when we extract Q meshes, so this extracts the entity material, and it does a thing, right? And then we have the extract plugin. Okay. Prepare resource. So this is my mapping of my like this maps each to its handle. I don't know. Okay. Okay. I'm not quite sure what I'm doing. Okay, so what am I like? I'm just like not mentally following. What am I trying to do? I'm trying to get to here and to be able to be like, wait, solid batch bind group. You. Okay, so we get rid of you. And you. Alright, best done. Okay, so prepare bind group. He'll run somewhere. So bind groups, and this is going to be res, and this is going to be super bind groups. Material bind groups. Alright. So it's not a resource. Well, it is now. Drive resource. And also and default. Right, something like that. So material bind groups, so we should probably also make sure at some point can we like render app be like, hey, to be honest, we should probably be like app.add plugins, extract plugin. Maybe we should rename this to plugin because there's no point going extract plugin. It's a bit weirdly named. And then we want to go bind group plugin like that. And then we're going to go plugin. Okay, like that, except it's just app, please. Okay, and then no. We're going to say app dot ins. Okay, well, if let render app equals, yep, else. Error. Bind group plugin, no resource, no render. So we have to import error from Bevy log error, I want to say. Okay. Okay, so no. We just want to be like init resource. material bind group. Okay. Bevy render app. Cool. So we insert the resource, then we go to the render and go, hey, so this stuff here, extract solid bind groups, finish adding. All of this is actually technically just part of the bind group stuff. So we can put it here. So depressingly, we need to go import bind group plugin. No, struct. Because we need access to finished, which means we can't do it as a function. Import plugin for bind group plugin. Fn build. Do that, except, you know, just maybe put this here, and then Fn finish, which just takes in that don't insert the resource again. Okay. To be honest, I actually don't think we need finish anymore because we're just going to be doing it inside the thing, but we'll leave it for now. So can't find plugin in scope. Why are we not just using the prelude, please? Okay, please. Okay, so we still need to bring bind group in. Right. So we insert the bind group resource. So that's that plugin going. Next, we need to, well, solid batch bind group is that thing. Extract solid bind group. Okay. So don't forget to do that. And then you take in material right, and then add fn finish mute self app. No, it's not in finish, it's here. We're going to say we need to be like app dot, call you app because that's what we're doing. App. Okay. App dot add system extract schedule extract solid bind groups. Okay, then we need to app dot add systems. Well, we just copy with this. Okay, that should work now. So you need to bring render in. We need to bring in render set. Okay. Right. So this is prepare bind groups, which is prepare bind groups. Right. So finish add render. What did finish add render do? Render device batch new batch. So that just like actually made the thing. Okay. So prepare bind groups, which takes in our render device. Okay. Batch, which is our material bind groups, like so, and our solid color pipeline for some reason. I'm going to qualify you because I want to bring you in. If batch changed and it lets some bindings batch dot bindings. Okay, so this is when we actually create the bind group, which is fine. Is also to do apparently. Okay, write solid buffers. So I'm just gonna say write buffers now. Material binders. So what we need each one to actually do is somewhere we like extract it is extract, isn't it? Right. So extract entity material. So this is where we keep track of what material is on what entity. So if instead of tracking the asset ID, we instead tracked the I don't know how this works, but anyway, like they do some kind of weird slab thing. But anyway, we're gonna say pub struct find group ID. Yes, which is just a U size. Okay, so with that we can go here, go okay, so render group doesn't have add render anymore, which is fun. And yours is called find group plugin now. Okay, so and you don't have finish either. Okay, so go to render. We go, what the hell is wrong with render at the moment? Solid batch pack. So we need super bind group, material bind groups. Okay. You also need access to res super extract entity material map. Okay, so this is materials, and this is entity materials, map. I guess, I don't know. I'm bad at naming stuff. All right, so we need to go let materials equals material into inner. I mean, technically we should call this bindings, and then this would be called materials. Right. So then we go, hey, let bindings equal bindings into inner, and then materials is the materials into inner, and then we go, hey, if let some ID equals materials dot get item dot entity. No, it's let some else return skip. Okay. So we get our ID, then we go let binding equal bindings dot get ID else skip. Okay, so you also need to be a sum. Right. Okay. Then if let some binding batch point. Okay, so then and then instead we say pass dot set bind group binding like that. Hey, okay. So we need to add get to both of those functions. So bind groups, and then we say import struct import material bind group get. Can we just like not do add for now because I have no idea what it's going to do. Okay, so self.bind get yep, and then map it into that. Okay. that seems like it should work, I think. I don't know. Right. So this is our right buffer. Buffer. Okay. my concern with that one is I don't think you're actually doing it at the right time. Anyway, and then you should also be material bind groups. Material bind groups. Okay. Right. Let's not do this. I don't think you're actually doing what I think you should be doing. Anyway, prepare bind group. Okay. So inside a render, let's continue working on it. So material, is it done? Probably didn't make it public. Yeah, fair enough. So first off, nope, it is public. It's probably the other one that's not. So also you apparently are not. Okay, so you should be super bind group ID. Interesting though. Right. So then yeah, you mapped the bind group and then. Okay, that should be fine. What was I doing? I need to import entity material map yeah, get, which then can I just you know, it's copied, and we're gonna go here and we're gonna say, hey, you are derive debug clone copy partial equal, yeah, whatever. You can do all of that, thank you. Okay, so we do this, we say copied. Interesting. So what I'm thinking is I don't know how Bevy was handling it, but I'm just going to keep a hash map of the fine. Hash map platform collections. Yep. So this would be a mapping of asset ID. No, just a bind group. It doesn't need to be optional because it's a hash map now. So bind group, right? And then we can just say, hey, can you like just get the accept that you're an asset ID. Okay. First off, can we just import this, please? Thank you. And just get still reference, thank you. So we call get, and then get gets us the binding, and then so we're gonna go down here and we go, hey, so then we go back to extract, no, render, yeah, extract. So the mapping is going to go back to being asset IDs. I hate doing this. Just shows how little I know what I'm doing. Yeah. So we say, hey, can you get this? Can we get the asset ID? Yeah. You should pass me a reference and just get rid of the copied. Okay, so that means that when an entity enters the world, we get its ID, we put the ID into the map, and then when we go to render it, we use the ID out of the map to get the bind group, and if the bind group's been added, we add the bind group. Okay, so then question, I do have a question about extraction, but we need to work on this. So first off, bind group ID can go away. So I'm trying to keep things reduced so that I can know what's important. So extract solid bind group. Interesting. Prepare bind group. Interesting. So at the moment, neither of those really want to be run. So somewhere, I think it's extract. When we say remove resource, something, extract plugin, we render asset plugin, right? And then so you initialize this, so you call extract render asset, and then you call prepare asset, and prepare asset extract asset, render. So this is run in where? I don't know, prepare assets. So this prepare assets thing, this system from all the assets of the corresponding type which were extracted this frame from the GPU. Okay, so rope asset count, queued assets, queued extract assets, remove contains or skip previous frame assets that have been removed or updated. We could check if available bytes is greater than byte length, but we want to make some forward program forward progress even if the asset is larger than the maximum bytes per frame. This way we always write at least one sized asset per frame. In future we could also consider partial asset uploads. Match a prepare assets as binding group error, return next update. okay, so that makes me think that if I go to material here and I say, hey, prepare asset, wait. Ooh, no, not my class of fucking water. What I'm not following at the moment is you call prepare asset. Does prepare like A, which is a render asset, prepare asset. We're passing the extracted asset, the ID, and the parameters. And then the B dot write bytes. Render assets dot insert ID and prepared asset. Right. The available bytes for the current frame. But like, what are you actually doing with them? So you call 0 and you call insert and then you call insert. But it's like a vector, isn't it? Hash map, right? Yeah. So what I'm not following about this is it doesn't seem to actually write anything to the GPU. So we say like param and core, and we take next and we iterate through and then we iterate through. And we say, hey, how many bytes am I writing? And then we say like some size, and then returns true if there are no more bytes available for writing this frame. But like, you're not writing anything. Prepare next frame assets to push ID expected that. Okay, unload asset. Or remove. Unload asset. But like extracted assets, extracted drain. We remove previous. To ensure that if we are updating the asset, then any users will not see the old asset after a new asset is extracted, even if the new asset is not yet ready, or we are out of bytes to write. Okay, write bytes if some size byte length exhausted. Prepare. So queued assets, extracted assets, and prepared. So by looking at that, it seems that it tries to queue first. It then tries the extracted. Okay. So what I'm not following about this entire fucking thing reset render asset bytes per frame is that it doesn't actually seem to be writing anything. It's like it legitimately is just, I mean, technically it's calling me, but like, by that logic, am I supposed to write it into the, like, that's what I'm not following, I guess, is that when I extract here, when I call prepare asset, like, is this my responsibility to, because it says after this step, the extract asset is transformed into a GPU representation of type render asset. After the extracted asset is transformed. After that, in the step, the extracted asset is transformed into a GPU representation of type render asset. But like, what do you mean? Like, am I supposed to pull in the bind group and bind everything? And could that be kind of funny? The thing is I need to go to like, I want to go maybe mesh, right? And then prepare asset somewhere. It's new, is it address usage? No, okay. Again, I'm starting to accrue lots of shit up here that I don't need. Okay, so set material bind group. Render material instances. Prepared material. Okay. The prepared material does it. So do you like read something? So well, you read the draw function, apparently. So we get a bunch of lots and lots of functions. And then render, and then mesh pipeline key bits, set. So what exactly is inside this binding? Material bind group, material properties, and some phantom data. So, so you at least queue yourself to be binded, right? And then this does this bizarre as bind group apparently. Unprepared bind group, which is why it needs to be material. Unprepared. Okay. Okay, so wait, what? Wait a second. Huh. Right. Material bind group index and material bind group slot. I still don't understand the index and the slot and all that stuff, but it does mean that, like, well, it's still unclear if I'm supposed to be well, I mean, you do grab access to the render device, so I mean, you can just make the bind groups as you go, I guess. So in extract here, no, in material, we go, hey, one of your parameters is an sres render device, and well, it still has as bind group as a thing that I can call, so that kind of implies that I can say something along the lines of well, we also system parameters. Can we bring in like res mute? When we need to grab mutable access to was it bind super bind groups, material bind groups? I think that's kind of it, isn't it? So then we can say something like that. Yeah. Okay. Can we say like let mute groups equals param1 dot into maybe I don't even need to do this. I'm completely unsure about that. Can't find render device in scope. Sure, bring in render device. Okay, interesting. Cool. So apparently we can just do that. Apparently the mural res, which is even more concerning, can't move out of parameter 1, which is behind shared reference. Okay. Nope. Nope. Okay. Okay. As ref. Okay. I don't know. Can't remember how to do that. Anyway. Let's just go with the fact that we can be like, let binding equal I guess source asset as bind group. So it does need its layout, bind group layout, render device, param, system param. Okay. Unclear what your parameters are, but okay. So your layout would be solid color vertex, bind group layout, render, no, that's param.0. Can we let device do that? Interesting. All right, so okay, so you need this. So that's the layout. So as bind group, you then need your
render device. Again, okay. Device. And what was that final thing? Params. So I don't know what your params would be. What the hell is your params? This implements as bind group. And this has as bind group, which is then self params. Self params. Any chance that I can okay, overflow either of on params equals underscore. Okay. That's a bit weird. Anyway. Can I do that? No. Mismatch type expected on apparently unusual params? Oh. Nope. So what the hell do you expect? As fun. Okay. Render assets GPU image or as fallback image. Wait, what? Excuse me? Import as bind group or I get rid of this now. I go, hello. Can you please like fill in all the missing members? So data. Data that is stored alongside the prepared bind group. Can you store no data alongside the prepared bind group? Params. And then we go, hey, layout, render device, params, force no bindless, unprepared. Okay, wait, unprepared. Returns a vector of bind group index owned bind group resource. In cases where owned bind group resource is not available, as bindless texture is currently force non-bindless is true to request that bindless textures not be used. Extracted materials used this in order to ensure that the base material doesn't use bindless mode if the extraction doesn't. Okay. Bind group layout entries. Turns a vector of bind group layout entries. As bind group. What is the default implementation of it? As bind group. I suspect that as bind group is just going to call unprepared and then prepare it somehow. I don't know. As bind group. What the hell? So bindless slot count none. Bindless support true. True if the hardware actually supports bindless textures for this type. Taking the device and device cost into account. If this type doesn't use bindless textures, then the return value from this function is meaningless. Okay. Label none. Okay. As bind group for self matching the layout defined bind group layout. Okay. Let unprepared bind group bindings data equals self unprepared bind group. Okay. Let entries bind group iter map index binding. Oh god, starting to die. Okay. Get binding. If past a
Material binder allied. Interesting. Okay. I still don't really know what you're doing. Create bind group. Self-label. Prepared bind group. Bindings. Bind group. Data. Oh, I think I understand what it was doing. So where did you get T from? T. Right. So it takes in self. Wait, where the fuck are you getting T from? I guess you're the one getting T, which is self data. Right. Which is why I think you were like vec. I guess you would just be a buffer, wouldn't you? Renders. I want to say it's just a buffer. Right, and then we go, hey, unprepared bind group. Okay, returns a vector of owned binding resource. In cases where owned binding resource is not available. So, unprepared bind group. Unprepared bind group. Binding. Binding resources. Field. A pair of binding index and binding resource used as part of a prepared group or an unprepared binding group. Okay. Can we not? Like, how the fuck do I make you? As bind group shader type? In current span, as what the fuck? So what did you do? So, okay. To be honest, I legitimately have no idea what's going on. So, let colors equal buffer new from no. Okay, so is it like a uniform? Oh. I don't know where it's coming from. New. Okay. Oh. Wait. What? Where B is buffer. Okay. Let buffer equal buffer. No. Okay. Render device dot create bind group. Create buffer. Buffer descriptor. Size, material size of.
usage, uniform, copy destination, mapped at creation, allows a buffer to be mapped immediately after they are made. It does not have to be, all buffers are allowed to be mapped at creation. If this is true, size must be a multiple of copy buffer alignment. Sure. Buffer. It doesn't feel right because the uniform buffer in its storage buffer, uniform buffer wrapping. Wait, no. In case call. Bevy render. You. I think that's the wrong uniform buffer. Is what I'm getting at. Render device buffer shader type on. Okay. So there was another option. There was a uniform buffer. So there's this one and this one. This one. New. No. Add usage binding. New. Get. Set. So there's you. From T, where T is shaded type. Okay. From self.colors. Okay. Scratch uniform buffer. Option buffer. Okay. We can just not do that then. And then bindings, and then we can say like binding. Can we say like okay to get it to stop like drawing red lines on everything? And then we say like data is no. I don't know if that's correct. I don't think that is from it. Binding resource. Owned binding resource. Yeah, wait. We can just do vec. It's just like that. Okay. Right, and then you'd be 0, comma color dot binding. Binding resource. But what makes it an own? Okay. Okay. Binding resource. Is there anything I can do with you? I don't think you implement anything. Can I do anything with you? Do you implement anything? Not really. The owned binding resource of any type, texture view, etc. This is used types like prepared bind group to hold a single list of all render resources used by binding. To be honest, no idea. So when I say buffer, set, get, add usage, write buffer. Self.label as defer, as deref, buffer usage, content stretch as ref. Creates a buffer and initializes it with specific data. Okay. So I run the device dot create buffer with data. What the? Can you not just make stuff up? AI? That would be appreciated. Okay. Interesting that you now have a mapped at creation and the other one didn't. Interesting. Okay. First off, let test equal uniform buffer from self dot colors. Okay. So what did you do when we write buffer, we say, hey, create buffer. Wait, I'm very confused. Create buffer with data. Label, usage, content. Why do you have map at creation as an option? That's because that's not the right type. Buffer init descriptor doesn't have all these fields. It has different fields. Right, so label. Okay. Debug label for the buffer. Color buffer, I guess. Contains contents. A reference to self.colors. Nope. Dot as bytes. Is that a thing that I can do? No. Well, and then usage is buffer usage uniform. Okay, so this. Okay, so my question about you uniform is how the hell did you pull that off? So when I call from uniform buffer wrapper, no. No, okay, so you get paid. So when I say goddamn right buffer, you say scratch dot right into shaded type. Bound sample BT. Interesting. So annoyingly, I'd have to run it into a scratch buffer apparently, which is just another uniform buffer, which is kind of funny. So wait, insert uniform buffer, and the uniform buffer has a uniform buffer that is a evacuate. Interesting. So you have write okay, and then what does write do? Asset uniform compact. Assert that self meets the requirements of a uniform address space or stored on storage. Store values and uniform addresses. Okay. So reference to T with T. Okay, and then it says uniform of self, and then it equals self dot inner dot right. Okay. And then you say writer, and then
new, and then value, and then buffer, offset, value right into. I don't know. That seems like a terrible way of doing it. Okay. Like, can I unsafe trans mute? Okay, so std mem transmute test. Wait, what? Don't transmute test. That seems like a really bad idea. No, transmute. Transmute takes in a type and turns it into a type, which means we need to transmute. I don't know if this is gonna work, but self dot colors. My concern with transmuting that is that you want a reference. Okay, so this is gonna be dumb, but I also don't know why I'm trying to do this in here. I should probably be doing it down here. Maybe? I don't know. You paired bind group. Bind group binding resources data. Okay. So can we just say like no to you being as bind group? I am curious if I can do it. Interesting. Well, apparently what I was using requires that. But what was that bind group doing? I don't remember. I feel like as bind group wasn't doing much. So you just get it as an unprepared bind group. And then you create the entries. Okay. So as bind group returns prepared. Okay. So again, let's turn this off. Let me go. Can we import solid color vertex like as bind group, which takes in like self and I don't even need to take in a layout, just render device, which is just a render device, and can you just like spit back me a prepared bind group, something like that, which has the bindings. I assume. I don't fucking know. Okay. So first things first is we just have to be like let color equal wait, is that a thing that we can do? See, I recognize the type white mark, so I'm curious if I can be like hello please white mark equals this. Hello. Yes. Wait, really? Is this a thing? Is this gonna work? Did the AI just like make something up and it's true? I hope it is. That'll be great. The AI just made it up. Just completely pulled in a random resource and it's like, no, this works. Yeah, we'll get there. So bite mark. Oh my god. Cast slice, which takes a slice of A into a slice of B when A is no uninit and any bit pattern. Okay, so cast A into B. Annex. This is try cast slice, but will panic on error. Okay. Some color. So I'm curious how you fucking do that. Unsafe. Internal cast slice. Okay. And you try catch slice. Okay. Something went wrong. Okay. So try catch slice. Input bytes. Core mem size of A. Note everything with line of and size of will optimize away after monomorphization. If a line of B is greater than a line of A and not is aligned to point a constant line of target alignment greater than input not aligned and input not aligned. Okay, and then size of B is else if unsafe raw parts. Oh god. Oh, just gonna. Good thing I didn't try to do it myself. So buffer uniform copy definition. Okay, so that's our buffer, and then we can say, hey, binding as and wait, what? But really? Okay, is it just a thing? No, because that's like a little different type. Anyway, we'll get there. We'll get there. Can we just do this now? Bind group is something. We'll get there. So we need to go like, can we be like the device? I would like for you to have like a FN bind group layout. Entry binding 0 fragment buffer uniform as dynamic offset false minimum binding size none count none. Wait, what? What are you complaining about? Label? Because I think you go like this, my dude. Create binding label. It's also not called a label. Right, and then maybe do something like maybe. Is this a thing that exists? It is. Okay. Apparently this is a thing that I can do. Alright. So bind group and everything like device dot create bind group. So label layout is self dot bind group layout. Well, it's not a self thing, is it? It's a solid color vertex as bind group layout device. Takes 2 arguments, but 1 argument was supplied. What do you mean? No. Bind group layout. Thank you. Well, it wants it to be a reference. Okay. So that works. And then so we say entries. Okay. So then entries needs to be like I also feel like you need to be below this because I need to create this and then so we're gonna say entries. We probably also want to take in our queue, maybe render queue. I think maybe so create buffer with data. We'll do that. and then we do this. We go, hey, that's not the right way to do that, but anyway. What do we want to do? This is like a owned binding resource buffer. Don't clone it. You own it. It's just yours. Okay, thank you. So then we say prepare, and we say, hey, data, no data. Bind group, and then we create bind group, and then we go, hey, entries. Can we say like bind group entries sequential with indices? Something like this, and like bindings. A reference to bindings. No. Dot getter. No. Okay. Consider borrowing it here. The answer is no. Okay. Single. I despise you to no end. So what do I need? Fucking you require to be constant. So you know it. So it needs to be. Alright. So we do something like a reference to you. Are you like bindings? No, wait. You wanted a reference to an array? God damn it. Okay. Let mute. Wait, can we just make it? Okay. Bind group entry. Binding 0 resource. No, entry. Another type. What the fuck type is it supposed to be? Okay, it's supposed to be a bind group entry. Okay, bind group entry. Binding 0. Binding is what? No, that's stuff. Index. Okay, fine. We'll go back to you and be like, not you. We go, hey, I need this type. Just need to go, hey, how the hell did you do it? You said entries is bindings, iter map, get binding. So material. So what are you saying? You were entries equals bindings dot iter but map index binding binding entry index and then as binding something like that. I don't know. That seems wrong. You say a get binding. You get binding. And you become a binding and you become entries. And you become entries. There we go. What the hell? Okay. Dot collect. Go back. Maybe. Is that gonna work? Who knows? Is that here? You collect into a vector and then you fucking pass it. Okay. I hate it. Okay. So, like, are you prepared? Are you up? Uh-huh. Like, so we have the buffer. We create it with the data. Does that mean it's initialized properly? See, like, well, my concern here is that first off, we're going to data. Bindings. We have a collection of binding resource. And then we create buffer with data. So we never called write, but I'm kind of hoping that when I say, hey, create buffer in it with the script, right, and then do okay. So skip mapping if the buffer is 0 sized. Okay. So if empty, else unpadded size descriptor content.len as buffer address. Valid Vulkan usage is buffer size must be a multiple of copy buffer alignment. Buffer size must be greater than 0. Okay. Therefore, we round the value up to the nearest multiple and ensure it's at least copy buffer alignment. Okay. Alignment mask. Copy buffer alignment is 4 minus 1. Padding size. Unpadded size plus alignment mask and not alignment mask. Max copy buffer alignment. Okay. Descriptor. Label. Padding size. Padded size. Descriptor usage. Descriptor usage. Map at creation. True. Okay. Buffer. Self.create. Buffer. Slice. Get. Map. Range. Mute. Unpack. Copy from slice. Content. Unmap. Flush any pending write operations and unmap the buffer from host memory. Create texture with data. Okay, so that tells me that it is in fact actually doing what I think it does, which means I don't think we need the queue, because what does the queue actually do? Queue. Handled command queue on the device. So, out of curiosity, if I said something like binding 0.1.write. Nope. If we were to say save this. Let test equal uniform buffer from self.colors test.write buffer. So you use the device in the queue, but what does it actually do? So queue dot write buffer. Schedule a data write into the buffer starting at offset. This method fails if data overruns the size of buffer starting at offset. This does not submit the transfer to the GPU immediately. Calls to write to buffer begin execution only on the next call to submit to get set of scheduled trends starts immediately. It's fine to call submit with no command buffer at all. Okay. Our data will be immediately copied into staging memory, so the caller may discard it any time after the call completes. If possible, consider using write buffer with instead. This method avoids any copy and is able to transfer more efficiently than normal. Wait, what? Oh, okay. That's interesting. Right above and drop schedules a copy of its contents into the buffer at all. Okay. Anyway, don't think that matters. So, I don't think we need the queue. We literally just write the stuff straight into the buffer and return this, and we go, yeah. This is pretty stupid, but anyway. We can get rid of this now. So something. Prepare asset. We do hey device param1, device param2. Then we go binding source asset. Dot. I mean, as bind group with device. Sure. Cannot move. Yeah. Okay, so we now have a prepared bind group, and something tells me that we want to go to this material binding thing, whether that happens to be material bind groups. We want to go, hey, can we be like prepared bind group that holds no data, and then we go, hey, when you say this, we want to go dot. And then group and turn some group is more okay, fine. And now you're telling me I can't do that. Mismatch type option. What do you mean? Expected. Bind group. Found. Option. Oh, yeah, just rewrapped it in some. Okay. Alright, so. I have no idea if this is actually going to do what I think it does, but we don't need to extract solid bind groups anymore, and we don't need to, well, let me just make it not crash, and yeah, see if it works. So I don't, again, know exactly what the extraction is doing. I would love to know what the hell this actually does. So when this prepare asset gets called, it literally just tracks how much stuff it does. What I don't like about this is it seems to be copying. Like, this just holds a copy of the asset, so like it's impossible not to have two copies. Whereas I would rather just copy it across into the view. Anyway, when we go back to our render here, and we say, hey view, can I like underscore these just so that you shush about them? Entity. Okay. Wait. Wait. Item query? Interesting. Okay. Yeah. So we say, hey, can we like bind group get? Okay. Sure. And then you just pass in the bind group, and then we go, hey, I guess maybe might just work. We'll find out. I mean, I haven't run the game in like 2 hours or something, so if this works, I'll be impressed that I didn't fuck something up. Whoop, click that button. It's almost certainly just going to crash because there's no way I've spent 2 hours doing this and I haven't done something wrong. But hopefully it shouldn't be too hard to like fix the small things that I've obviously fucked up. And then I should, well, Command Q. Okay. So I didn't like that. Consider removing duplicate access. Okay. So. Panicked at system parameter. Okay. Error. Res solid color bind group material in system conflicts with previous. Okay. So apparently, not here. In what one? In prepare bind group. Apparently, I've got 2 copies. In prepare bind group. Okay, yeah. That would in fact make a lot of goddamn sense. Just grabbing a mutable and an immutable copy of the same resource. Oh, I don't even use it. The function does literally nothing. I knew I did something wrong. Well, it didn't crash. But did it work? The answer is no. Okay, so there's only a few places it could go wrong. All of them are right here. Binding into. So my assumption here is that we'll first put it on print line. Has no material and has no binding. Right. So we're gonna find out if it's getting here or to here without having problems. My assumption is that I'm calling like something entity, item.entity. Entity placeholder has no material. Yeah. So that's funny. But my suspicion is maybe that I'm queuing the wrong entity. Why is it placeholder? Okay, so P is phase item. Phase item has entity. So it's like it knows the entity because I'm like it's been given the wrong entity. Now, presumably, like the most obvious thing to be going wrong here is that when I pull my bullshit and I is it an extract? Where the fuck is this Q material mesh? Do I like at any point tell you? I say, hey, opaque mesh material has no material. Mesh instance mesh asset ID. So when somewhere I queue render entity and visible entity. So render entity. Can we get to here? Can we just like please print line print line? And I want it to be render entity and visible entity. And I need these to be debug. So the question then becomes, because this is obviously going to spam it even worse, but like, am I somehow just ending up with placeholder entities? I mean, it's entirely possible. Well, that's interesting. Well, it only got there once. So, first off, we need to stop it from spamming. Is it render? So it's saying entity placeholder has no material. Okay. Stop saying that. We'll leave the other one because if we end up getting here, that'd be interesting to know. And there's a pretty obvious place, but again, it's more to do with the fact that see, it's fucking placeholder main entity. Why is it placeholder? Like it knows that they're different entities because it says 13, 12, 12, 13. So it knows the correct entity. It's just the render entity here, which okay, for each entity the view can see that has our material. You suck. So how the hell? So placeholder implies, right? Box material. So visible entities. So when we call visible entities data, is this a thing? Self render visible entities get QF. QF is the type. Okay, and then we and then so self. When we say get render visible, so it's a type ID map. no op hash. Okay, and then we vec, and it's got an entity and a main. So what that's telling me is that it hasn't actually spawned it into the what? No, surely not. Does it get a thing when I'm underneath and like it should be rendered? No, of course it doesn't. Why is it a placeholder entity? Well, we're probably queuing you at the wrong time, to be honest. Where am I putting that? When are you running? Prepare mesh bind groups. Write material bind group buffer. This stuff is really badly made. Specialize. I've written so much of this stuff so long ago, I have no idea really what it's doing. Prepare meshes. Specialize material meshes. Queue meshes. In queue meshes. So it's queuing it at the right time, apparently. After. A subset within queue where mesh entity queue systems are executed. Ensure that prepare assets render mesh is complete. Okay, so after prepare assets. Render mesh. Okay. So it does say to, you know, make sure that happens. So prepare assets render mesh. Okay, but I can't imagine that prepare assets render mesh will actually do anything because again, it's something about the visibility that it's implying that like the entity, you know, it's just like visible entity. Render entity. It's just not making it to the world, and my suspicion for why it's not making it to the world is that like the visible entity. I'm assuming when we review, you only have you have a main entity. Okay, render visible entity. Interesting. Like my curiosity here is more like somehow we're not actually spawning the entity in. And I mean, admittedly, that makes a little bit of sense because I'm actually just taking the data and storing it myself in that extract. Like, is it view? So this comes from the camera. Not you. No. So like in theory, we could probably maybe stick it here, and then instead of looking it up like I am, maybe. Maybe. I don't know. My suspicion here is that we're not actually spawning in the corresponding entity, like, and therefore, because the corresponding entity never gets spawned in, we don't insert material. Okay, so is it main? Can I call it main entity? Right. Type dot entity. I don't know. Did you also have an ID, which also did? Okay. Weird. Is there a difference between main entity? So we call ID, and it calls self.id, and if we call entity, info contains and okay. All right. Anyway, so we use the main entity. Okay. But then that does mean that when we extract entity materials here, we need to make sure that we well, I think we're already using this. Never mind. I assume that you don't overwrite that and put that one, so that would actually mean that like you have the correct one anyway. So it wouldn't have worked anyway because we would have been loading onto the wrong entity. That's lost its material last round. Okay. Well, so index 1 generation 0. Well, you know, it would help if we were also using the wait a second, how do you this is asset ID. Okay, cool. So render, and then we go here, we go hello, show. Well, so you would be correct because you are getting something out, and it's a different something, which is good to know. Now interestingly, it should be flickering both of them, but it's not, which concerns me to a certain degree. The reason I think it should be flickering both of them is it should be alternating back and forth about which one, but maybe it's because it's skipping it. I don't know. Like maybe when it does skip, it skips the whole batch. I'm not sure. It still doesn't make any sense. But anyway, so mainly what's going on here is that you contain it. The binding doesn't contain it. So we have material binding group. So we go hello, you get initialized. So it's the material here. Okay, yeah, well that would make sense, wouldn't it? Bind group dot add insert asset ID binding. That would help. And then we probably also want to be like fn unload asset, and then your params would be something like param dot one dot remove source asset, something like that. And then we just need to go to you, which is you. I'm going to do just insert Fishx mutable self asset ID in a group, and then remove, and does the same. Okay. So kind of funny that I just like completely forgot to just put it in. Like I went all the effort of generating the bind group and then just like dropped it. I don't do that. Interesting. Lovely. Okay, so you didn't like that at all. You very much did not like that. Hilariously, we made it so much worse. Okay, so you panicked at validation error. Okay, so handle, so caused by in render pass end, if a draw command kind multi-draw index count, the bind group layout with solid color bind group layout label of current set bind group with at index 2 is not compatible with the corresponding is not compatible voxel material label of render pipeline with solid color voxel pipeline. So my assumption is that I fucked up this bit here, because I said your fragment buffer uniform has dynamic none. Now, what did I say that the pipeline uses? Voxel material bind, so yeah, you. And then how did we get you? We said render device create bind group voxel material array buffer. So no. So entry. So create bind group layout. Okay, so this is the material layout, which is fun, which means that we get to go here and we get to go, hey, can we say solid color voxel bind group layout? And then pass in the render device. We just need to import the solid color voxel. Apparently private. Okay. Okay. I mean, that should fix it, I think, because we literally just had the wrong type. We said it was an array, but it wasn't. Solid color bind group layout. Well, it still didn't work, but anyway. It didn't spew a massive error this time, which is nice. So something validation error. So it says that in device create render pipeline label equals solid color voxel pipeline. Okay, that's you, yeah. So, pipeline. Solid color voxel pipeline, yeah. I mean, what else is going to be crashing? Error matches shader fragment, shader requirement against the pipeline. Shader global resource binding group 2 binding 0 is not available in the storage class. Uniform doesn't match the shader type. Storage access load. Matching shader stage fragment. Shader requirement against the pipeline. Fragment. Shader defs, shader, entry point, target. So the issue is that shader class uniform doesn't match the shader storage access shader access load. Okay. Count. Visibility. So shader storage. Fragment. This is visibility. Fragment compute. Yeah, okay, so that's probably not what it's referring to. I think it's probably gonna be type and then type uniform. Okay. Right. And then it has to count. Okay, so doing something wrong. Bind group layout entry. That or it's so usage. Storage class. Oh, you know what's wrong? The shader said it's a storage class, but it's not. It's a uniform. Right. I dislike, it's probably because it's baked in somehow, that when I edit a shader it needs to recompile. Hey, well, it got closer. It still crashed, but like it rendered something first. Then we're back to a really long crash. Okay. So what is your problem this time? Yep. Okay. Multiple indirect buffer is bound with size where the... Wait, what? Okay, so let's get the calculator up. I'm gonna go, hey, so we have 256 times 3 times, unless it's 4 bytes per 3,720. Okay, so that's the number of bytes we actually did, and where the shader expects. Okay, so annoyingly, and I'm guessing, yeah, there's 4, so if we just muck it in. Shader, so something, get material. You're a pain in the ass. So let's make you a vec 4. It's got something to do with alignment. I don't know what the shader alignment is, but surely the shader type should pad it out. Well, it probably does. I'm the one casting it to a slice. Anyway, so we may get a vec 4s. Well, it's going to complain and not compile because we did this. And we're going to go, hey, to vec4. Okay. We'll just add more data. That'll fix it. No, vec4. Thank you. Swizzle. Because the other option is to pad it. My assumption is that it can't. What size does that make it? That's like 4K. WGPU minimum. Oh god, no. Minimum buffer alignment. I want to say it's something to do with create with data, and then we say create buffer, and it said something about here, and it says okay, so create copy buffer alignment buffer address equals 4. Buffer to buffer copy as well as buffer clear offset and size must be aligned to this number 4. Okay. I don't think it's rendering. Okay, it is rendering and it's printing out the entire shader to do it. So it's not working, but anyway, I'm still confused about why this would set my unpadded size. So it's saying it needs to be a multiple of 4. But why did you expect it to be bigger? Anyway, why are you spewing out god-awful amounts of issues? So this is my code. Okay, pipeline not ready. Process shader error. Composer error. Shader invalid error with span, entry point, fragment, name fragment, source source function expression handle for source compose component count give for expected. Okay, so this is almost entirely because when I say render, I say like, hey, when you have an issue, can you just print out the issue? Pipeline not ready. Can you just like not? I mean, we'll leave it for later, but for whatever reason, it's not liking that. I'm hoping that when I run this, because I'm no longer printing out every time, it'll just like tell me the compiling error. But something in here is not compiling, is what's going wrong. Okay, there you go. So what did it say? Ah, I'm padding out a color to a vec4 that's already a vec4. Also, can we like stop it from printing whatever it's printing? Okay. First off, I'm going to comment you out because I don't care. And then we're so probably in extract we're printing something. Commit Q here. I just don't do this anymore. Lost waste of time. Is it going to work? Well, they're both white, which is incorrect. Which is annoying. Why are... okay, out of curiosity, are they going to go red? Ooh, now they're green. Now they're white. Now they're green. Right, they're batching together because I didn't tell them that they're not the same one, so they're batching together. Okay. Good, good. So how do I split them into their own batch? Be interesting. Cache. Nope. Interesting. I actually have not. We should look at Bevy PBR and see if it's standard material to that, but anyway. So what's happening is that because we're batching them together, they're only loading one. Because it's running one and skipping the other. Because I think it said somewhere that it does that. That's how it like gets around it. So whichever one you see first is the color that you'll get, which is, I mean, at least it's going in the right direction. Add identity to a so So we're getting rid of this, adding entity to opaque phase tick. Okay, this can probably go as well because this is not necessary. All right, so here's the thing: batch set key and bin key. I don't think either of these I have control over. Opaque key asset ID. Ah, the asset that this phase item is associated with. Normally, this is the ID of the mesh, but for non-mesh items, it might be the ID of another type of asset. Okay. Opaque. It's somewhat annoying in that I literally can't bin together two assets. Which is silly, but anyway. Batch set key. Information that must be identical in order to place opaque meshes in the same batch set. Aha. A batch set is a set of batches that can be multi-drawed together if multi-draw is used. Right, so I need it to be in here. So they need to share a pipeline, they need to share a draw function, material group index, the ID of a bind group specific to the material instance. In the case of material binding group index. Aha. Index slab. Okay, so it's the material bind group index. So okay, so that does mean that we need to say something like let some material index equals mesh. Okay, so we need to bring in the materials, which is res super entity material map. Okay, dot get visible entity. I mean, visible entity is the main entity, so sure. Dot ID. Else continue, sure. So we say material index, and then we go. Now, how do I say like some material index dot hash ID asset ID. Okay, so can I let map material ID equal material index match material index? So the idea being that I'm pretty sure you have UUID and some, and then you would be material index, material ID. All right, so then you would be asset ID index, right? And then also you would then also be, you need to do this, and you need to be UUID and a marker. None of a marker. Okay, cool. So no, but funny. So you my friend are So material index. Material index. Before I was looking at you. So asset index. Generation and index. The unstable opaque index of the asset. So we can just return index dot to bits. No. Index dot. If I call bits on you, do you set the high or the low generation? The low. I just don't want it to waste the time. Why am I not allowed to just take the asset index? It's public to the crate, bits, from bits. That's it. You're only allowed to and from bits. Okay, thank you. As you already do. Just gonna cast it down. Okay. And then your UUID. So as braced. I'm curious what braced means. Yeah. Okay, self as const UUID. As const brace. Okay, fuck you. As what safety UID and braced have the same ABI? I mean, they do. In literally the fact that like this is just a formatting thing. Why? Okay, whatever. Dot as you. This will truncate. That should be okay for everyone. Thank you, AI, for like stating that it's fine. You can. No way. Is it like this to say that I don't care about you? Okay. So the idea is that we take the index, and then so now they are different numbers. Oh. So if they're the same mesh, they go in the same bin, which they'll never be the same mesh. So ironically, you know, we could just give them the anyway. One of those is green. The other one is white. It's working. It's fucking working. I don't know why it does that, but I do question why is the ordering kind of fucked up. Pipeline core opaque. Yeah. What is this lighting slab? Who was it that should set this to? And none. I don't know. Oh god. Actually hurt. Now I am dying. Oh god. Okay, so mesh slab. Okay, so oh god. Okay, so what am I doing? What am I doing? Oh god. Oh, I'm dying. Oh, that was horrible. Okay. Still dying. Okay, so I have no idea why you're rendering on top like that. You work fine. You do not. My assumption is that the depth is not correct. Where the hell is your shader? This shader. I don't know if I'll find a square it does. So it's possible that whatever I'm doing there is just wrong. I don't know what's wrong with this one. It really doesn't like it, but it's identical to what I'm doing here, except for like the fragment stuff. But let's face it, the fragment stuff should not be doing anything. So that does kind of imply that it's like a culling issue. So, I mean, what do I actually pass between them? Vertex output. So instance index position, well, normal block type scale. Yeah, so nothing, and then fragment turns color. So it's not doing a depth map, which could be a problem because I think this one does do a depth map. Maybe let's have a look. So we go to pipeline. Vertex depth stencil. This that if your view has no depth buffer, this will not be changed. This will need to be changed. Okay, so depth stencil state format core, which is depth F30 to blue. Okay, depth right enabled. If disabled, depth will not be written to. Okay, depth compare always. Okay. Comparison function used for depth and stencil operations. Okay. Stencil state. Okay, what the hell is the stencil? Stencil state. Stencil for this. Read mask, write mask. State of the stencil operation, fixed pipeline stage. Use in depth stencil state. Corresponds to the position. Okay. And bias. Okay. So first off, depth right enabled true. So fuck you. Why would I not be wanting to do that? Depth compare always. So my assumption with depth compare always is that that could, you know, okay. So first off, you're not supposed to be rendering back faces. I don't know how to make it not render back faces, but you're not supposed to be rendering back faces. Anyway. Compare, greater? Function passes if new value is equal to existing value. When used this comparison function, make sure to make your vertex shader built-in position output and okay, greater. Function passes if the new value is greater than the existing value. No. Less. Okay. So if we do that, then the depth stencil should work. Function passes if new value is less than existing value. Okay. Greater? You mean what? Okay. Okay, well, now at least works the way I expect. Okay, that's fine. Okay, probably add one at the like top level so that I can be more than just a horrible white. I like it just a solid block because they're all the same block at the moment, which is what's causing this. Anyway, so depth stencil apparently greater works. That's very bizarre, but okay. Multi-sampling. Count mask alpha T. feel like this will break if I change my MSAA. So the question. I'm just gonna fix this because I feel like if I ever accidentally change the pipeline. So from world, okay. Ah. That's why we did that. Sure. Well, technically it makes it more robust, but it's not actually going to. We're just going to pass the exact same thing in here. But it means that in the future, if I ever do get the thing working where it, like, where I actually like pick the right one, that'd be good. I don't care about you. You're doing your own thing. So in our map here, can we like generate maybe a second map? Yeah, just do it again. Do it again. But this time, set color. Okay, so we want to go like maybe like let you colors equals. We also don't care about the Y. Oh yeah, we're already doing that Y equals 1. Yep. We want to say like X plus 10. I guess map size times 1, 2. I don't know. Sure. Okay, so we do this with a mesh material instead. No, it's not mesh material. Block data. No, it's not a mesh 3D. It's we want a voxel material. Color. Okay, no, so we want to say let color equal this here, and then I want to say that you are color, like that, right? So then that's a handle. We want to clone new, right? Right, like that. So then we want to say that this color, I'm going to say for okay, these, and then we say set color linear RGB CCC. No, because that's just going to be shades of gray. We want color hue saturation lightness, and the hue is going to be C. Okay, sure. Saturation is going to be 0.5, and I think lightness we want to also be 0.5. Okay, then we know set color. No, 200. Okay, so that should give us all the colors, which should give us like the different blocks will be different colors. And then that should work, I think. Yeah, no. It's gonna look a little weird because like again the blocks are just like really bright, but that's fine. We really need to tidy this code up. Okay, so that's all grass. Okay. Ah, yes, it's literally not even checking what block it is. So next is to get it to actually let me edit the code while I have it running. So I wish I could do the symlink thing that I was doing, but I'm pretty sure that's still fucked. Yeah, it probably actually works. I don't remember how to do this. Pipeline shader something. Sure. Wait, you don't even need to be mutable. Alright, weird. Yeah, why do I let it not? Okay, just apparently apparently just return the type, like that. Okay, somewhere in here. Can I get you to remove the unused inputs? Somewhere. I have lots of unused inputs in here apparently. Alright, cool. Somewhere. What was I doing? God damn it. Brain, why do you do this? Right, somewhere I load the shader. Mod. Yeah. Load internal asset. Kind of wish this is my one, isn't it? No, this is Bevy assets. We can't support parameters without verity, and so parameters can't be hot reloaded. Wait, what? Okay, so ident handle ident explorer path loader params. Okay, we can't support parameters with verdict argument. So internal assets with additional parameters cannot be hot reloaded. Yes, but let mute assets app role mute resource mute create assets. Okay. Assets insert handle ID loader include string path string std path new file parent unwrap join path string to lossy string. Wait. Interesting. So if I came back to like here and said Bevy features equals embedded no, let's just go to docs.rs. That seems like a smart place to go. Should actually refresh my chat and make sure I haven't been out of broken this whole time. Okay. Your Bevy. Yep, and then we're gonna go, hey, the list of features. Can we say that watcher file? There it is, file watcher. So I'm pretty sure there's like an embedded watcher. Yeah. Enables watching in-memory assets provided by for Bevy asset horizontally. I don't know how this works because surely if they're embedded you can't read them. I assume that's what that whole the whole extra section there, load internal asset, this bit. So we call loader and we pass in this and the path. So we include the string, path string, and then we pass the parents. How does the embedded watcher work? Yes, Bevy embedded watcher. But a watcher, it's a watcher for assets stored in the embedded asset store source. Embedded assets are assets whose bytes have been embedded into the ROS binary using embedded. Wait. Loads an internal binary asset by embedding the bytes shared with a given path string associated with a given handle. Okay, yeah, that's fine. Using the embedded asset macro, the watcher will watch for changes to the source file, reading the contents change file from the file system, overriding the internal static bytes of the file encoded into the binary with the new dynamic loaded file. Okay. Okay. Interesting. So, hopefully that works. I don't know if it does, but this states that it's by internal by embedding it, so I would assume this works. Migrate to the asset.png. Okay. This is horrendous. Well, it's doing something, maybe? Okay. So they're all still pink, but like the idea is that if I pop you here and pop you here and go, if I modify, I want to say this one that's loaded, this and said, I'm pretty sure the vertex output consists of a block type. So if I come down here and said that instead of just loading the color, I want you to load in.block type. Did it reload it? No. So do I have to do something special to make it watchable? Load path string and associating it with the given handle. Does the fact that I've turned the default features on you off mean that it won't watch you for changes? Mod load internal asset. Embed asset. Create a new embedded asset by embedding the bytes of the given path into the current binary and registering bytes with the embedded asset source. This accepts the current app as the first parameter and the path relative to the current file as the second. By default, this will generate an asset path using the following rules. Search for the first crate skr in the path and trim path past that point. Re-add the current crate name to the front of the path. For example, consider the following file structure. Bevy rock skr sender rock lib rock w0 in the way shadow again. Another wants to bundle with this crate. This invoke following in embedded asset rock can now be loaded by the associated path embedded rock renderer. Okay. Some things to note in the path. The non-default is trimmed from the path. Okay. The default behavior also works with cargo workspaces. Pretend that Bevy rock crate now exists in a larger workspace. The asset path would remain the same because embedded asset search for the first instance of rock skr in the path. Okay. For more standard crate structure, the default works just fine. But for some niche cases, such as cargo example, skr path will not be present. You can override this behavior by adding it as the second argument. Okay. But for some niche cases, such as the cargo examples. Okay. When there are 3 arguments, the second argument will replace the default value. Note that these 2 are equivalent. App rock. This macro uses the include bytes macro internally and will not reallocate the bytes. Generally, that asset path generated with will be predictable, but if your asset isn't available for some reason, you can use the embedded path macro to debug hot reloading. Embedded asset that is supported, just enable the reloaded cargo feature. Yes, but it doesn't seem okay. So, bed asset, and then we got app. Solid color.wgsl. Something tells me that that's all I need to do, because now the asset's embedded and none of you return anything to it. Ident create asset in fucking world resource embedded asset registry path watched path. Okay. Embedded.insert asset watched path include bytes. Okay. Why'd you put an extra comma there? Okay, so we can embed it, and then next, after we've embedded it, we need to load it. So load embedded. No. Okay, so annoyingly. Annoyingly. How do I pull this witchcraft off? So let mute asset app and insert. So this just pulls some shady bullshittery. So we'll be like let mute asset server equal right, and then it's something like can I say like app dot load? No, asset server dot load acquire okay, begin loading an asset type storing stored at path with holding a guard item. The guard item is dropped when the either the asset is loaded or fails to load. This function returns a strong handle when the asset is loaded and enters loaded. Okay. Acquire override. Same as load, but you can load assets from unapproved. Okay. Acquire with settings. So path and S and then G and then A. Okay. The setting function will override the assets associated loader settings. The type S must match the configuration of the asset loader setting. Acquire settings override. Nope. Load folder. Load override. Same as load. Except you can write okay. Load state untyped. Asynchronous. Load with settings. Is loaded. Register loaded. Get asset loader with. Retrieve the default asset loader for the given asset type. No. Get dependency. Get path. Kind of wish there was like a load into. So when I call load, you return a handle, right? And then so this is load with meta transform. Okay. So this again just returns a handle. When do you acquire the handle? You're returning handle, and you got handle infos.get or create path handle. Path.clone handle loading mode not loading request. Oops. Interesting. Asset dine. Meta transform. This is documentation. A pointer type that uniquely owns a heap allocated allocation of type T. Meta transform. Okay. Guard. Type needs to be dropped. Override unapproved. See unapproved path with more details. Interesting. Shit. Interesting. I do wonder because I feel like I was doing something in the like new version of Bevy might have like a way of doing this. There was like a load. I think it was the shaders were like loading parts, and the way they did it is that they would like load it and then didn't really have this fun inserts the handle with the ID and then the loader, and because it bypassed the asset server, it just doesn't have a problem. Whereas the shader one was like load internal shaders or something, or like a load shader parts, and the way it worked, I remember, maybe load shader parts, something like that. And it's only in the new version, so it's like 0.17 or whatever. My default thing goes to bevy.org, bevy.engine.org, and then it always just redirects me to bevy.engine. So where was it? It was like something like Bevy, no examples. Crate render script globals lib somewhere so we're on the latest, so show me something shader handle. Where is this used though? Load internal asset. It's not a load internal asset. That's weird. Maybe they got rid of it. No, that doesn't make sense. Why would they get rid of it? Main, maybe? I'm on the latest, but maybe it's main. Actually, that would make sense because I would assume latest is latest release, not latest. Yeah, load shader library. So just grab this and bring it over so that we can look at it on screen instead of over on GitHub. So they've got this new one called load shader library. Inline shader as an embedded asset and load it permanently. So so it just calls itself for one thing, which is kind of funny. Oh no, so it embeds the asset, right, that you passed in, and then it goes, hey, let the handle equal shader handle create load embedded asset. And then it forgets the handle exists, and it's just like a way of like permanently loading something without having to keep handles everywhere. It's literally an intentional memory leak, which is great because like you're not really going to unload parts of shaders. Kind of cool. I do think that'd be kind of cool, but it's not until the next version, and it's also I don't think it would help because I need to associate specific handles. Yeah, and the main reason this works is because we're bypassing the asset loader, which means that we don't have to forget about these handles because they're weak to begin with. So I don't know how I would do it. We kind of just need to be like, well, I guess what I can do is I need to comment both of these out too. So it's like create the embedded. I need to create the other embedded. Wow, actually they're both the same. Yeah, both the same. Okay. So we create the solid color, and then we get a pipeline, and pipeline's going to complain because we need a handle. But we can just say let that's it. Server equal server. Right, and then you should be able to say like asset server.load, and then it's like embedded, and then I want to say it's like that, and then solid color WGSL, except that's not going to be correct because it's going to be annoyingly it's gonna be like Phoxels solid color. Maybe I should rename you to and then we go to, where is it, like mod, and we go, hey, can we just call you shader? Right, shader. And then we go oh, I think we've broken this now. Great. Well, we'll restart our thing for you. Can I get like restart, please? Anyway. We go here. So we're loading shader, and then we go to, is it pipeline? And we go, can we load solid color slash shader? So it would be I guess it's Phoxels slash. Okay. So we have to go back to here and be like, is that how you say this works? So it's create name. So embedded dot slash slash create name and then path. Okay. So pipeline create name embedded Phoxels solid color shader. Okay. And then because everything else points from there. Oh god, that should work. All right. So you don't like this. I'm gonna like restart code. Nope. I should probably fully restart code. Let's just close all of these. Save whatever the hell I was doing there. What the hell is this? Probably shouldn't have that open. Code. Okay. This is not the right project. We need to go to projects. No, it's going to be different. Projects. Bevy, not Bevy Jam. Say voxel shader. Yep, it's like this. If it never recovers, I'm going to be so annoyed because it was working. Anyway, okay, so then you load shader, and then we go to terminal, and we go run, and we find out if we can then modify it from the embedded source. That would be nice. How do you do your fancy loading? So ident source path. Scar. Yep. Okay. Path embedded. Watch path is embedded path file. Insert action. Interesting. Anyway, it still doesn't seem to be working, which is interesting. So guess the question is it actually going to change anything? So can we like render? Did it reloading embedded change? Okay. Can we load 255? It reloaded it. It didn't fucking do anything. Can we return 1? Okay, so it's doing something. It's just that apparently the color's the same every time. So that's fun. Can we no just return color? I don't know why it's always red. No, that's a bit weird. It has something to do with you, and you're like, hey, when do I generate this color? Don't clone it. Okay, see. Okay, so let step equal. What's yes, okay. So no, the answer is it's 360 divided by I as f32. Okay, that's what we're going to pass C in. So the idea is that because it's 0 to 360, we're passing in like basically 0 to 1. I always forget it's the. Yep. Well, apparently it's still the same, but that's because it's all grass on top. And okay. Oh, that's clearly distinctly a very different color, but stone is not. Okay. Also slightly taller, but I think it's just general world gen. Okay. So I mean, I guess the trick now is just to start like making the shader actually look like a shader. So let normal. Don't I extract the normal now, I think. World normal. Yeah, so we should probably like right at the top grab our color. So it's gonna be like var var color. Something like that. Right. And then we go okay. I don't know how to do this. So we go wow. If normal.y is greater than 0.2, dp equals 1. This is the face overrides. It's with stride. Block type. Block type equals in block type plus stride. Bar block type. Let x equal block type percentage. Okay. UV. No. These are all about doing textures. Somewhere there's a bit about like tweaking the color ever so slightly. If A is less than discard TS. Okay. TS times equals DP times color. What is DP? TS. Okay, so TS was the original color we were returning. Let's start removing stuff that doesn't matter. So TS times equals DP. Now where did fucking DP come from? So DP. Okay, so basically var DP, and then this, and then this. Okay, so we go here. So world normal. I do kind of feel like the world normal is a little bit of waste of memory there. I should probably just be passing in a number, not a float. But anyway, y. So ironically, it's in dot world normal. Yep. Yep. In dot. Okay, cool. Right. So doesn't seem to have done anything. Right, because we need to multiply times dp, and then we just say color dot a equals 1. Thank you. All right. Did that work? I don't know if that worked. It does not appear to have worked. So what it's supposed to do is, if you come over, you can see, like, this is less obvious because these are all the same. Like the grass obviously has a quite clear top. But it's like, so you can like see where the corner is. It's like, you can only do that because technically this is slightly darker. Like that's what the, like, if z, it's if x we add 0.2, and if z we minus 0.1. So the idea is that like each face only gets one modification made to it, but it's like the tops will be brighter, bottoms will be darker, left and right will be like, so it means that like if you look into a cavity like this, you can see the corners like that were here. Like you can see this corner. It's because they're actually slightly ever so slightly different shades. But for some reason, which I suspect has something to do with the fact that they're just returning solid colors. So first off, if I just times you by, let's say, like 0.1. Okay, so it is actually darker, right? So DP should be working. But again, it all just looks like the same color. So, okay, so if x is greater than 0.2. Well, one question is, can we say if world, because I'm probably not using world normal correctly. If world underscore if in dot world normal dot x is greater than 0.5, then dp equals 0. Right. So that should mean, yeah, okay. So apparently none of these x's, none of these sides are an x, world normal of x. So how the hell do I extract the world normal? So you don't like this because you don't know what this is. We have to go track that down. So let's go like mesh functions. We're going to go get world from local. Let's go track down that in the GitHub and find out exactly what this function does. But no, I need the actual declaration. Include function, there. Okay. So apparently, we turn this back on. We do this, and we can do this, and then we go, hey, look, get world from local. You don't like that because something about mesh instant index. What? Right. Because something, where's mesh coming from? Okay. We had to include Bevy PBR, mesh bindings. Mesh bindings, mesh. Okay, you still don't like this. Well positioned to clip. That's interesting. This is mesh functions. So the declaration of mesh is, maybe I spelled mesh bindings wrong. No? Okay. So in bindings.in, in, What do you mean? Unknown identifier. It's probably because we need to make sure that this happens here. There we go. Okay. So this really doesn't like it. Can we like again I need to like restart you. I don't think restarting it really helps because it still doesn't like worker panic line library invalid offset. It's because it breaks its cache and then it doesn't want to work again. I don't know how to get to recompile its cache. Time to eat something. Okay. Sorry about the horrible racket while I eat some food. Okay. So then we go in here. Here we go. So you don't like this because vertex.position. What do you mean? Why do you not seem to accept that ampersand is a valid thing? No overload for found U32 I32 expected one of. Yes, but it is that. Like that's a you issue, not a me issue. Okay, don't like that. Vertex position. Okay. So instance index. So position. So you're U32 and you seem to think that these are I32s? Can I say like you? No. You? Okay. I don't like that I need to specify that these are U32s. Do you not have a problem with it? It's the same like you seem to think that these are I32s. But they're not though. Anyway. Alright. And then mesh functions, mesh position to world local. Yeah, can't find mesh scope, I don't care. As long as you work up to the point that I'm currently in, I don't care. Okay, so out position, also position, world. Okay, so what I need to do is I need to somewhere encoded into this information is the actual the normal. Okay, so we need to be like, well, I guess it's I don't think I ever used the normal for anything, but we're gonna be like const normal cube normals array. Yep, okay. So front, back, right, left, top, bottom. Well, it knew what I wanted. Now I gotta go into the scary underbelly of whatever the hell this code does. Mesh generator, maybe. I don't know. Somewhere in here we encode the data. Somewhere we encode the data, chunk size dot bits per axis. Okay. So n is the normal encoding, and that is apparently somewhere. Fuck knows. So bits per axis, which we need to know what medium chunks bits per axis is. Medium 5. So wherever that was. God damn it. Mesh gen. So it's 5, 5, 10, 15, and then ID. Right. So your 15, and then your 15 plus 8. 15 plus 8. brain's not working, calculator. 15 plus 8. And you should be, I'm going to say there's 6 of them, so you need to be 3 bits wide. Right. So you're 3 bits wide, so 23. So then let normal equal vertex dot position shifted 23 u and it was 7. Okay, and then we go up here and I go, hey, your world normal, I mean technically it's supposed to be something else, but anyway, is just a u32. Thank you. And then we're gonna go down here and we're gonna say, hey, instead of like putting it there, can we say like out dot world normal is equal to that encoding. We say out dot world position equals mesh function mesh position local map. Okay, so then we come up to here and we go, hey, this doesn't work anymore, but that's because you're going to use let normal equal cube normal in dot world position. Okay, so then when we save this, well, something's happening. I mean, if normal dot x, wait, what? So z, right, is x, y. So y exactly, if normal dot x is greater than 0.5, dp equals 0. So the one's on top, which implies that x is up, which it's not, but okay. But why do you think that x is up? X, y, z, so this one, x is greater. So that doesn't goddamn make it. Anyway, the rest of it's working now. I mean, leave it. Everything should work, but I'm still confused about why normal dot x would be on top. Does that mean that I'm encoding it wrong here? So n p 0 to normal encoding. So to normal encoding. Wait a second. Oh, this is just not correct. Okay. Well, apparently I was storing something else in there, because that tells me which vertex of a cube it is, not the normal of the cube, which bizarrely enough, I mean, might be right, but what it means is this, and this all have different normals because they all share. Like this one shares 3 faces, so which normal does it get? So, okay, weird. You know, you just uncomment the piece of code that calculates the world normal. We just say normal. Like that, and then we comment this one out. We go, hey, it work now? Indeed. Indeed it works. Okay. So next I guess we well, outside of removing this completely unnecessary thing here. But ironically, we should probably factor in the sun to do this, but yeah, that seems like work. What was I doing? Oh, I was making the chunk size dynamic. This is because at the moment you have to give it exact size chunks. So the thing with that is we would probably want the binding to be well, interesting. See, I don't want the colors to be shared with the thing, so what I'm thinking is we can first up we're gonna go like ampersand, and then we're gonna like group and like 2 and binding 1 time. Okay, no, this is going to be a storage, I think. Storage. Okay. This is going to be size, and it's going to consist of a U32. Well, that's an array of a U32. We won't know how big it is because we won't know how big the batch size is. So now we have to work out again, which terrifies me because every time I've tried to go, hey, I just need to work this one simple thing out that Bevy's already doing, so it already should be really easy to solve. When exactly do they fucking set all the meshes into the batches so that I know how to get the fucking instance ID? So somewhere, draw mesh. Draw mesh, I'm going to assume that if I go up a little bit higher, set mesh bind group. Maybe not. Okay, so set mesh bind group. You bind, I assume every single mesh onto the GPU at the same time, which seems like a really bad idea performance-wise, but you know, set mesh bind group, set mesh bind group. When set bind groups, something, mesh phase bind groups, something. Somewhere it's going to say like set bind group, and it's, I want to say 1. Yeah, so bind group and then dynamic offset. Okay. Current morph index. Okay. Current skin index. Dynamic offset. Right. I don't like this. But yeah. So dynamic uniform indices. Right. So set bind group. Set the active bind group. So how did you pick the bind group? Mesh phase bind group get. So mesh asset ID. I'm assuming light map slab index is skinned is morph has. So my assumption is that you don't actually care about the asset ID. Maybe. So self mesh phase bind group morph targets mesh blend group pair. Okay. Get. Okay. Okay. So well, so no morph targets. Well, if it has a light map, some. Okay. Okay. Model only, Azra. Right. So this is just a bind group, and if model only means okay. So that to me says that you must just literally, when we say is it view bind group, material bind group, set mesh bind group. All right. So you just set the bind group, like you don't actually load anything. And then when we draw mesh, I don't think we do anything either. Like I assume. So batch range, item dot batch range, indexed. Mesh allocator. Mesh. Oh, mesh index. Return the buffer and range within that buffer of the index data for the mesh with the given ID. If the mesh has no index data or was allocated, return none. Okay, but I don't think. So we set vertex buffer. See, and that comes from like the slice. Vertex buffer slice mesh asset. So somewhere we use the mesh asset. Mesh CPU mesh. So this is the render mesh. Okay, and then vertex buffer slice takes in the asset ID as well. Okay. That's a vertex slice. So what I'm trying to work out. It doesn't look like it. But maybe it does. Is I feel like every single mesh like must be loaded at the same time. So what if we did what if we did that to pick the color? So we go up here and we said can you just go like at local for dummy U32. And then come down here and we say, hey, so out dot dummy equals vertex dot instance index. But to avoid no writing to output error. The fuck do you mean? The AI is cooked sometimes. Anyway, I want to pass in in.dummy. Right. So now terminal. We run the game. It's annoying, it has to embed this shit back in. What I'm hoping to see is that they all have different colors, like each chunk. No, each chunk should be the same color. And well, I don't know what that means. I guess that just means that they no. Each chunk should be a different color. Now concerningly, you see, a lot of those chunks look like they're the. Oh wait, no. So any chunk rendered in its own batch. Oh, okay. No, that is concerning. Because that does in fact mean that their transforms need to be specific. So, to be honest, I don't even know how it's getting different colors, but so that implies that not every single one has an unique instant ID. That or that the instance ID is incredibly unstable, but so what the hell populates the material? Yeah, so it's something like a mesh set mesh binding, mesh bind groups, render mesh instances. Is it you? One would assume it's render mesh instances. Right. But how? I guess I know when. It's gonna be mesh. Is the pipeline? So mesh bind group. Where do you pull the mesh bind group from when you set the bind group? So you say here, and then up here, it's like, well, what is it? So it's group. Okay, mesh phase bind groups. So, and mesh phase bind groups comes from match bind groups. Okay, that's fine. Mesh bind groups. Bind groups. Mesh bind groups. When the hell? Okay. All bind groups for mesh are currently. Okay. Model line. Well, that's it. Like it's Okay. They only have one model only. Wait, no, this one doesn't. This one has lots, but we'll ignore this one. I'm assuming it's because it needs a different one for every single type of thing. I'm mapping the type ID of a phase, e.g. the mesh bind group of that phase. Okay, yeah, because it's like the opaque needs different input data. But as you can see, they all have only a single model, which means... Right, yeah, so if we can work out when exactly this is getting created. Okay. Hello. Welcome to the stream as I slowly eat. Okay, so we insert the resource information. But when do we actually populate it? This one does the same thing, prep mesh bind group. Interesting. So you make this and then you insert phase ID mesh bind group. Okay. Instance data builder. That's some instance data binding. Okay, so this is an untyped phase batch instance buffer. Phased. I think I've been through this rigmarole before. Now, my concern with you. Phase instance binding. I need to track down you, which is you, which is you. Which is you, which is a batched instance buffer. Current input buffer. Previous input buffer. Phase instance buffer. So, again, I'm completely thrown by the fact that okay, the GPU buffers holding the data needed to render batches. For example, holds mesh uniforms with the other BB type of that model. We have a specific buffer data input type here. With a compute shader is expected to extract the full buffer data type. GPU uniform building is generally faster and use less system RAM at 2 VRAM bus bandwidth, but only implemented some pipelines, for example, not in the 2D pipeline at the present, and only when compute shader is available. Okay. But when do we populate this thing? To be honest, I think I'm going to run in circles again. This is annoying. Alright, so I need to work out when the hell you are used. I've actually completely lost it. Where the hell did it go? Okay. How do I lose? Okay, so I'm going to copy that. We're going to go over to the Bevy thing. We're going to swap to Bevy 16. Wait, there's a 16.2 now? No. When did 16.2 come out? Batched buffer. Okay. So meshes. I'm in meshes, right? Yes. So ignore the ones in meshes. They don't do anything. Resource exists. GPU processing. Run if resource exists. Prepare process bind groups. Okay. So if we go to, is it render? Then was it called GPU? Is it called rendered? BPR scr render. And then it was called GPU processing. Wait, how did I end up here? This is not. Apparently it still exists in 16, so I'm more confused now than I was before. Oh, it's probably just one higher. Yep. Okay, so GPU processing. Okay, so it's used like 12 times. So this is a run if that we don't care, and this is a resource, world resource. Batched instance, okay. Node, early GPU processing node. Batch instance buffer. Okay. I just want to know when exactly you extract it and how you know which is which. Let pipeline. So first off, why are you just like never using this again? Where? Okay. Loop over every render phase. Okay. Is that just gonna it? Untyped phase buffer. Okay. Work item buffers, last index, parameters buffer. Buffer that holds the number of indexed meshes that weren't visible in the previous frame when GPU. Okay, this is fucking horrendous. So the index of the buffer data in the current input buffer that corresponds to each instance. This is keyed off each view. Each view has a separate buffer. Okay. So, wait. You look useful because retained view pre-processed work item buffers. Okay. Last indexed indirect parameter buffer. Okay, a buffer that holds the number of index meshes that weren't visible in the previous frame. Okay, so weren't visible in the previous frame when the GPU cohesion culling is in use. This one sets the Bevy uses this value to determine how many. Okay, Bevy. Bevy uses this value to determine how many threads to dispatch to check meshes that weren't visible next frame to see if they were because they became newly visible this frame. Okay. Last non-indexed indirect parameter buffer. A buffer holds the number of non-indexed meshes that weren't visible in the previous frame. So, work item buffer. Pre-processed work item buffers. The index of the buffer data in the current input buffer that corresponds to each instance. Right. Untyped data buffer. Okay. Pre-processed work item buffers. I feel like that's what I want to look at, because that'll be like, I can find out, grab the work item buffer from the view. Oh, get, okay, oh, there's our phase work item buffer. Okay, where do we use this? Down here. So, process work item buffer, indirect. GPU occlusion culling. Okay, here's, I still don't understand. Let mute dynamic offsets, small vec, dynamic offsets, push, uniform view, to offset. I feel like I need to do something with the bins. Last index bind group. If there was no space reserved for work items, then don't bother doing the dispatch. There can't possibly be any meshes with a given class indexed or non-indexed in this phase, transform and cull indexed meshes if there are any. Maybe last indexed bind group. Compute push set push constants. 0 bytes last indexed of offset. Compute pass set bind group. Right. But like how do you know? So you do this, so you do this, so you say untyped. Phase instance buffers. Untyped instance buffers. So untyped phase instance buffers. It's got to be this. Yes, untyped. Okay, so data buffer. A storage area that, for the buffer data that the GPU compute shader is expected to write to. There will be one entry for each index. Okay. Interesting. Okay, the index of the buffer data in the current input buffer that corresponds to each instance. The index of the buffer data in the current input buffer. This has got to be what I want. But like it's confusing. Because this basically says where in the input data. And it's like, oh, I need to know where in the input data. I need to know what the input data is more accurately. So there's GPU processing. So you pass this and you use this and you go, hey, so when do you, so we use this and we say, hey, get the current view, which is this phase. When do we break this up? This goes to the top one, which is that it's indirect. So we don't care if the phase item was direct. Okay, the indirect. And then, okay, so that first up, let's go here and go, okay, so direct is a raw buffer. The work items are, we use if we aren't using indirect drawing. Because we don't have to separate indexed from non-indexed meshes, in direct mode, we only have a single buffer here. Okay. Oh, the representation shader are in one mesh. In our view. Right. Indirect. The buffer of work items we use if we are using indirect drawing. We need to separate out indexed meshes from non-indexed meshes if this case, because the indirect parameters for these two types of meshes have different sizes. Okay. Okay. Process work. So they're both processor work item. All right, and it tells me what the work item is. The next question is, how the fuck do I work out? So what do you do with last instance? No. So you don't actually do anything with the ID, which is, to be honest, slightly more confusing. Phase work item buffer. And then you just don't. Okay. Last indirect parameter indexed offset. Okay, the offset into the untyped last where the view indirect dispatch counts from indexed meshes live. I don't fucking get it. It makes no goddamn sense. Last indirect bind group. So, because we built the phase into pattern.
Okay. Maybe last. Indirect. For the mesh push step for single render phase of a single view. Okay. Phase processing bind groups. Last index bind group. Set push constraints for subsequent dispatch calls. Write the byte. For example, if offset4 and the data is 8 bytes long, this will call write data to bytes 4 to 8 and push constant storage. Okay. Set bind group. So dispatch workgroup indirect. Last indirect. So where did this come from? Last indirect buffer. So that came from you, which came from you, which came from the batch. Okay. My question is, where the hell do you fucking get populated? Pre-process bind groups. Okay, I think this is where we were. So, what throws me completely? Something's calling a run node. Early GPU's processing node. But where does it get? I'm so confused. So we do run. Wait, is it a different run? Late GPU process. Okay. Okay. Fair enough. Are we still in? Yep. Okay. Reason needs a lot of arguments. System that attaches the mesh uniform buffers to the bind groups for the. Yep. See, but it's only res, which means that it's not being populated here. Okay. You suck. So, back to GitHub to see if there's anywhere else that this goddamn type turns up. Okay, so screw batching. Okay, so is it Bevy render? Okay, well that one seems maybe possibly it. Okay, so Bevy render screw render phase mod. So it's not that one because that resource exists. Insert resource, and then that one is just using it. Confusingly, it says it only turns up in 4 files, which is just not. So it reckons that if I just go to where this came from, which is renderer, like, I guess it would make the most sense for somewhere in here, even though it's used so many goddamn times. Can we put a space so that we only find the ones that are the actual type that won't? Okay, so there's you, which where, okay, and then the default just defaults everything. That's acceptable. The new just calls default, which is, you know, hilarious. Delete old work item buffers. Okay, well at least it's goddamn mutating it here. Phase item buffers, value mute, work retain, render view entities, retain. Okay, retain view entities. Extracted view. Okay, so this is like dump out all the views that are gone, which is looking promising.
collect buffers for phase. Okay. Batched instance buffers. Okay, so insert the phase batch instance buffers into the global table. Replace the content of the per phase resource with the old batched instance buffer in order to reuse allocations. Okay. If let sum okay. Interesting. Insert into the global table. Place the contents of the per phase resource with the old indirect parameters buffer in order to reuse allocations. Use old. Okay. Write instance batch buffer. It's just going to call write buffer long buffer. Okay, so the render device queue, and then we batch write everything. So clear indirect parameter buffer. Now write indirect parameter buffer. So the thing I am not following here is where the hell it get GPU processing, culling input buffer, instant input uniform buffer, uniform data input current. Okay, uniform data input for the current frame, instance input uniform buffer. They are updating during the extraction phase. These are uploaded during the extraction phase. Holds the GPU buffer instance of input data, which is the data about each mesh instance that the GPU provides, via the buffer data input type, where the GPU mesh propagate shade is expected to extend to the full buffer data type. Okay. Previous input buffer. The uniform input data for the previous frame. The indices don't generally line up between current input buffer and previous input buffer because, among other reasons, entities can spawn and despawn between frames. Instead, each current buffer data input uniform is expected to contain the index of the corresponding data buffer input uniform in this last list. Okay, the data needs to be rendered buffer each phase. But the key of this map are the type IDs for each phase. Okay. So this is the input buffer. The bashed instant buffer. So can we go like, do you at any point grant access to this current input buffer? There's 4 places in the entire thing that you use your current input buffer. One of them is instantiating it, the other one is fucking reading it. Okay, well, that's completely useless. Mod. So maybe if we go to the this is not the right thing. We want to go back to batching. Okay. No GPU processing. This one's easier because it doesn't do like the compute shader, but so you clear the instance buffer, but when do you like batch, prepare, sorted, render phase? So batched instance, so it could be populating it here, except it's not mutable, so I don't know how. Oh, because it goes into inner. Okay. So it could be doing it there. Phase, sorted render phase, I, param. Okay, so GB param, and GB is get batch data. So a trait to support getting data using batch draw commands via phase item. Draw commands via phase item. This is a simple version that only allows for sorting, not binning, as well as only processing, not preprocessing. For those features, see the full batch. Okay, but I don't care. So what we're doing is so the params, yeah, means that we're actually like fetching something specific to meshes. They're the mesh uniforms. The parameters for a mesh uniform, which means that params, system parameter, get batch data. Okay, so get batch data. Get the per instance data to be inserted into the array. If the instance can be batched, also return the data used for correlation with deciding whether the draw can be batched. Else return none for the compare data. Okay, so buffer data. Right. So entity, main entity, buffer index, batched index, buffer, push. Okay, so the ordering, annoyingly, doesn't seem to be here. Param. So param, param. So for something for I, buffer data type parameter may need drop. So buffer index. So get batch data. But see, my suspicion is that getting batch data and giving it an entity and a main is just literally going to return itself. Index is buffer index to index. Right, which is because when we say push, you return a GPU array buffer index. Right, so this is the buffer index, and then we say batch range extra index item, batch range and extra index mute. Returns a pair of mutable references to both the batch range and extra index. Phase, okay. And then we say batch range is from index to index plus 1, which is, it's just 1, so I don't know. Phase item extra index. The extra index associated with some phase item alongside the indirect instance index. Sometimes phase items require another index in addition to the range of instances that already have. These can be the dynamic offset indirect. But like dynamic offset. So that's fine. Maybe dynamic offset. Optional not okay. Non-max U32. Okay. Batch range and extra index mute. Right. Compared data. Okay. So batch and prepare sorted render phase. So phase. And then process item. New I. Where's I coming from? Cached render phase item. Cached render pipeline phase item. Sorted phase item. What the? Okay. So batch and process. So item phase item something batch data process item. So item batch range mute. Batch time. So phase item, hit a mute. Okay, so we can go phase items. Apparently this is a thing that we can do. Is we get the sorted render phase. And then right. So I don't know where this sorted render phase is coming from. Is it a resource? A collection of all items to be rendered that will be encoded with GPU commands for a single render phase or a single view. Okay. Each view, camera, shadow, casting light, can be have one or multiple render phases. Okay. Okay. This flavor of render phase is only for meshes that need to be sorted back to front, such as transparent meshes. For items that don't need strict sorting, bin render phase is preferred for performance. Okay. So render phase. Is it a resource? Is it something I can look up? I remember this from somewhere. Render. So somewhere we queue the meshes somewhere. So somewhere there's like is it extract? Maybe. It shouldn't be, but it might very well be. So yeah, nope, that's queue material meshes. So where the hell is the something opaque phase? Where did I get opaque phase from? What did I pull it out of? Opaque phase, validate cached entities. Okay. So let's call in something on opaque phase. Opaque render phase gets you retain view. So you are a binned render phase of the opaque variety. When I say add, do I get something back? Do you like kick back something? Like potentially, nope. Okay, 5 plus. Okay, so the interesting thing with that is that I feel like outside of the fact that at some point it's going to call render, and then render I feel is just going to run forever, like. But in theory, I don't know actually. Opaque phase add. So what was it? I don't remember where I was. It's got to be something in here. So like when I call add, what does add do? Add something pre-processing only. Okay. Bin new entity. The phase type specifies whether this entity is a processable mesh or whether it can be binned with meshes of the same type. But what do you actually do? Match phase type. Update cache. Okay. Main entity. Cached bin key. Batch set key. Bin key. Base key. Okay. Update cache. Render. Encodes the GPU commands needed to render all entities in this phase. Okay. Render batchable meshes. Render all meshes. Render all batchable meshes queued in this phase. Draw function. World resource. Draw. Let render device. Multi-draw indirect. Self.batch set. Dynamic uniform. Batch set. Direct. Multi-draw indirect. Render unbatched meshes. Render non-meshes. Okay. Prepare for new frame. Render cached key. Grow entities. Change entities that changed bins. Unbatched bin. Self unbatched meshes domain. Validate cached entity. Okay. Sweep old entities. Remove entity from bin. Removes the entity from a bin. If this makes the bin empty, the function removes the bin as well. If this this is a standalone function. Okay, lovely. So bin render phase. Bin render phase plugin. To be honest, I have no idea what the fuck's going on. Sort bin render phase. So batch and process bin render phase. Okay, so something tells me that the batch and process bin render phase. Sweep all entity. So batch and process. GPU. So this is the batched instance buffer. So this is the no GPU processing. So for bin in phased batchable mesh value mute batch set small vet bin render phase batch main entity bin entity self get bin batch data. Get the per instance data to be inserted into the GPU array buffer. This is only called when building uniforms on CPU. If this GPU instance buffer building part, we use get index and compare data instead. What the fuck is G? Okay, get full batch data. Right. So we're passing the system parameter and the main entity. Creates batches for rendering phase that uses bins when GPU batching build is in use. Okay, so instance. GPU array buffer. So surely if I iterate through, the issue is that I'm pretty sure it'll just render them all. Like it's not gonna give me another instance. Okay. GPU array buffer. Push. GPU array buffer index. Buffer data. Right. Instance. If the dynamic office has changed, flush the batch. There is this is the only time we have more than one batch per bin. Note that dynamic offsets are only used on platforms with no storage buffers. Okay. So batch set dot push bin render phase batch. Instance range. Information about a single batch of entities rendering using bin phase. Okay, batch set. Right. Maybe dynamic offset. Batch. Batch set last minute. Batch instance range and equals instance index. Wait. You what? Instance. Is that instance? Yes, instance.index plus 1. Wait a second. So how did you get that instance? You said you pushed it into that, and then the GPU array buffer index is returned. Batch instance buffer, yeah, okay. Batch last minute, okay, it's phase item set, dynamic uniform batch set, push batch set. Direct doesn't do anything, and dynamic uniform batches set should be using if okay. Prepare unbatchable. Okay. So batched instance buffer. So here's the thing. It appears the whole batch instance buffer is written, which means that, right, because you just write them in one at a time. So all I need to do is iterate through binned render phases, binned render phases. Right. So, okay, so iterate through those. Iterate all phase mutably in an arbitrary order. Your elements type is. I don't like that you say in an arbitrary order. My assumption is that the arbitrariness isn't like a hash map where it's like it'll be the same every time until an item is added and then it'll be different. Because it just means that as long as I will bin in phase batchable mesh, I don't quite instance GPU array do a buffer. See, because the thing is that you push every single one of those per phase. Maybe, I don't know. I don't think you ever clear it. It's the key point here. And the trick is, if you don't clear it, then it means that they all have to be there. But that may be only when you're in CPU rendering, which is going to be a pain, because... So what do I need to do? I need to go into whatever the phase item is. So I need to get the view binned render phase. Stores the rendering instances for a single phase that uses bins in all views. These are reframed, but storing them in a resource like this allows us to reuse allocations. Okay, so binned view render phase. Okay, so if we go back to like, I guess it's extract. So we're gonna be like make. I don't remember what I was doing. I'm trying to pass in mesh data. Instance. I don't know. Okay, I gotta come up with a better name for it than that. Jesus Christ. Okay, so it needs access to phase, which is a res, and it needs to be I assume an opaque 3D. Like, I can't think what else you'd put there. Right. Batch set keys. Bin keys. Representative entity. Okay. Batch range. Phase item extra index. That's the opaque 3D. Stores the rendered in. Okay, so what was it? Was for phase in phase what? Phase editor dot. You know, it wasn't. Is it something? Kind of want this real estate back. If you wouldn't mind getting rid of all that garbage. GitHub. Okay, so what is this? It's a phase values mute. Okay, so interesting. So values. What does this return? Binned render phase. Interesting. So what the hell do you even hold, actually, to be honest? A retained view entity. Ah, okay. So for each entity. Right. So for every camera, basically. It's interesting. Then we go for target bottom in phase dot render. Don't render it. It's interesting that we have access to. Okay, so what was it? U. So after that, we say bin in batched meshes. Dot batched meshes. Dot iter. Okay, so item. So we have a batch set key and a render bin. Opaque batch. Okay. So your bin for main entity and entities keys. Entities. Input uniform index. Wait. Returns the index map containing all entities in the bin, along with the cached input index. Input uniform index for each. Doesn't that sound exactly like what we want? Okay, so this is, I guess, bin, and then for entity in bin dot. Okay, well that looks completely wrong, which tells me that one we're in like a no. We must be in the no GPU version, which means it's slightly different. What the hell? Batchable meshes. Values. Batchable meshes. Values. Render bin. Entity. Dot. Iter. Okay, main entity. So input uniform index. So entity and index. Right? Something like that. Now, the question is, again, still, is every batch done at the same time? I'm going to go with the fact that this is doing this not, because they should all be different colors if it was. Which, maybe they are. Maybe it's just that there's lots of reds. And this just sometimes they get really bright. That doesn't seem right, but yeah. Whatever. So that's concerning because I have no idea how to view binned phase items. So when something calls render, it's got to be with a graph. I think I need to add like a node, which is concerning. The node scares me. The node very much scares me. When are you doing this? Like, you're not doing this inside a node, but something was doing something inside of a node. And you do weird stuff because you're not real. So main entity and entity keys. Let some buffer data. Get bin batch data. Get the per instance data to be inserted into the GPU array buffer. Okay, so the thing is I need to find the GPU processing version of this because like theoretically it'll be doing different stuff. So I reckon untyped phase batch. Do you have a node? Node. Something somewhere had a node. Batching mod. Batch and process sorted render phase. Node? Nope, you don't have a node either. Get batched data. Interesting. Get full batch data. Get index and compare data. Return the index of the buffer input data that the GPU preprocessing phase will use. We always insert the data during the extract phase before we get here, so the function should need to look up any render data. If the GPU instance buffer binding is in use, this function will never be called. Write batched instance metadata. Sort bin render phase. Batch. So what I should also probably do is say like if in dot dummy equals 1 0 return white. Cannot find iron scope. You mean not can't find iron scope? Question. So wait. Maybe. Okay, so there's only ever one because there's only ever one instance. Okay. So modulo 2 equals 0. Should we make half of them black? Which half is a bit random, but half of them black, which means that they all do have unique IDs. Okay, so that's one of my concerns with it. Now I just need to be able to get the correct data put in, because that does mean that I'm right in that in extract. We now have this entity associated with this index, I guess. Input uniform index. So that's where it is in terms of the instance. Okay. So that means we just need to say something like hub struct auxiliary mesh data. Okay. So auxiliary mesh data. So this is going to be like it's a size data, I guess, which is just going to be a U32, because I'll encode everything into it so that it's not transferring lots of data back and forth. So entity index bin entity and entity. So we need no, you need to be a vector. Maybe no, you'd be so derive come on. So I think about it. So your derive resource and you would just be I guess buffer, and you'd be a uniform. I want to say it's this one, uniform buffer, and then the uniform buffer. No, it's not a uniform buffer. It's a vec. Buffer vec. Okay. Like a rec, but doesn't require that data type T be non-init. This high performance data structure that should be used whenever it's possible if the data is more complex than is suitable for all the okay, so okay, so we then need to say something like resmu auxiliary mesh data. So when we get to here, we're going to say auxiliary mesh data dot buffer dot clear. Okay. And then so the question is index. I'm pretty sure you, whatever you are, no, it's you batched meshes render bin you, so it's okay. So dot 0. I would like to print line like something like this, and then I'm going to put it in the stream if this, especially if this doesn't work. I'm going to run out of fucking time. So we want to do this, but we want to go extract. We have an extract plugin, yes. Okay, so we want to go hey, so add system to, I don't know if it's extract. No, it would be render and then we want to prepare. Make measurements dot inset render set prepare resources, maybe. I want to say prepare resources. Can we disqualify these as render? So the idea is that first off, it's going to happen every frame. So let's just restart this and go, please, for the love of God, print out batch range. Oh, it crashed. Because I never initialized the resource, I bet. Yeah, okay. So we have to render app dot init resource. We have to do that after, don't we? Have to do it. God damn it. Impl from world for auxiliary. So render device, render buffer. New. I assume, yeah, buffer usage. Apparently not. Buffer usage. Let's say all. Don't have time. Apparently, you don't actually have to do that, which must mean that it's when I write the buffer that you need that. So anyway, that means that we can just go here and say render app dot init resource. Something, I don't know, auxiliary data. Auxiliary mesh data. So when we run this, I'm hoping that it prints them out in order, because if it prints the index in order, then I can just ignore the index and just paste them in. But I don't think it will, because it's going to be iterating the bins in order, and the bins, maybe though. No, probably not. Well, apparently the answer is none of them. Is it not running? It's got to be running. Can I get it to run? What's the other render stuff? So there's cleanup. What do we run it in cleanup? I want to see, because the issue is if I'm running it too early, when am I queuing stuff? Extract does the queuing. It really shouldn't, but it does. So one thing is it doesn't seem like I'm actually queuing anything. So when do I actually call you? Must be here. Okay. So okay, inset render set queue meshes. So we go back to here and we go inset. So we got to go to render set. Okay, so we queue meshes. So we prepare meshes, and then we queue sweep. A subset within which where meshes have been become invisible or change are removed. Phase sort to do this could probably be moved in a favor of system ordering a abstraction in render or queue. Prepare. Phase sort. Sort the render phase and bin keys. Yeah. So maybe phase sort. I don't know. Well, if we went this, when is? I don't think it's you. When is this from? Well, apparently never. When is this from? Apparently never. Okay, so fuck knows when you're using this. You bin phase. God damn it. Okay. So run this. Why am I not finding this? Can I extract? Can I print line new phase? Am I just like not getting here? View bin interface. So okay, so getting to new phase. So what if I said run after? The other option is that it's in the wrong thingamabob. After Q meshes. And when does Q meshes run? Pretty sure it's in prepare Q meshes. Yeah, it runs in render. Okay, so if I said after Q meshes, then it should, no matter what, where or what happens, it'll run. So extract. I go. So it's printing new phase a lot, but it's not actually doing anything. So that tells me that we are probably. Can we print line phase? My suspicion. Don't batch meshes, please. Just can we just print the whole thing? Is the whole thing debuggable? No. Can we? So there's a multi-draw meshes. Each batch sets key map to batch set, which is so non-mesh unbatchable meshes. It's possible that they're all unbatchable. The trait debug is not implemented. Dot keys. Okay, or key in. Not how that works, but okay. Can we print line? No. Okay, so it's not the key then. Really? Okay. So okay, so we want to like print line. You want to do like something like this, and then say key dot entities dot len, I guess. So this would be ren. This is batched. Okay, so let's comment this out because we actually want to bring that back when we've got this working. Do this, and then we go okay. So phase dot. So batched multi-draw. Multi-draw. Dot. Non-mesh items. Okay, apparently that doesn't have a index map, so can we say key.len? Non-mesh entities. Key.len. Okay, and then so wait, what? Okay, it's just not a call this time. And then finally, I think the other one was unbatchable. Then we say unbatchable. Unbatchable bin entities dot len. Okay, so if I run that, we should at least see which one has stuff in it, because there's a chance that they're not in the batch. The bin corresponds to batchable items that aren't multi-draw. Because if it turns out they're all multi-draw, aren't they? Multi-draw meshes. Wait, okay. Why is it sometimes rendering 64 or something? Okay. And the only time there's ever anything is it's all just multi-draw meshes. Okay. So for multi-draw meshes, which multi-draw meshes? Okay, the multi-drawable bins. Each batch set key match maps to a batch set, which in this case is a set of meshes that can be drawn together in one multi-draw call. Each batch set is subdivided into bins, each of which represents a particular mesh. Each bin contains the entity ID of instances of that mesh. The entity IDs of instances of that mesh. Right. Okay. But opaque 3D bin key. Wait, what? So index map opaque, which is just a mesh asset. Right. So here's the bigger issue. I don't think these are necessarily in order. Interesting. So if I was to, because first off, multi-draw meshes. Apparently there's 65 meshes. One. Okay, so can I get you to like maybe print for mesh in bin dot keys. Multi-draw mesh. So he's gonna fill the console with a lot of garbage. So like dot ID dot asset. So my interesting thing is, are they? I don't know. Not gonna really work. My question is they are they in the order, the same order each time? Well, first up, I think. Oh, actually, I do have a start point. Yeah. So it says that there's 46 of them, and they start with 64. I don't know how it says multi-draw meshes twice without any of them multi-draw meshes actually having anything in them. That's very confusing. Okay, 64. So this one's at 65, and then we go down to the next break. We go. So they're in a consistent order. Okay. Okay, which means that we do that. We go, hey, can I so as long as I don't move, they're in a consistent order. Make mesh in so buffer. So the buffer. So we don't use that. So the auxiliary buffer, we're going to say, hey, when you get here, we'll have to store that somewhere, but for now, we're going to say, hey, for each mesh in here, the concerning thing is that you're an index thing, and then we say mesh bin keys. So this is like for each view, phase.multidraw meshes. Okay, so let's say let I equal 0, let new j equals 0. So for each loop of this, we're going to say j plus equals 1, and then for each loop of this, I plus equals 1. Then we're going to say auxiliary mesh data dot buffer dot push that's a j shifted 8 plus I. Yeah, plus I. Okay. So do that then. Okay. So the value of the constant no loop. What do you mean? The variable j is used as a loop. Further, okay, no, so you're complaining because I'm okay. I don't care. So we do this. We say, hey, push this value, and then when we get to the end of here phase, no, here. At the end of here, we're gonna say write buffers, and we need Ren render device, and render queue, and we have to like qualify both of these. Okay, like that, and then we go, hey, can we say render device, render queue, right buffer. So you'll write that. You write that in. I don't exactly know what I'm going to be doing with this information, but can I by any chance I don't know what type you're going to be and what the fuck you are. Right. So I need to when I make my pipeline needs to grab this vertex material layout bind group. So I want to modify your bind group because it seems like it'll be easier. Then comma. Okay, bind group entry, binding 1, no, your fragment. To be honest, I don't care. Your type is buffer, your storage, read only, just true, has dynamic offset false, minimum binding size is none, count is none. That should be fine. Okay. Wait. Type. I kind of just want to say that you're actually a uniform, but I don't know if that'll work. No, leave it as a storage buffer. Okay. Then when we go as bind group, yeah, you can't do that because you don't have access to the thing. Prepared bind group. Damn it. Okay, well, one cheeky thing to do would be to go. Where was it? Extract, and we're gonna pull auxiliary. I need some kind of way of being able to mush these together, but auxiliary mesh data bind layout, bind group layout. Then we need to just paste this in. Okay. Qualify. We'll import that now. No, that's correct. It's that it needs to be bind. What do you take in label? Sure. Solid color auxiliary mesh layer. What is your problem? Because you keep fucking turning this into like a weird descriptive thing. No. Wait. Where's the other one? Okay. Device create bind group. Okay. Fucking render device. Solid color. Mesh group. So this is a fragment. It's a buffer. It's a storage group. Alright, so true. Okay. And then we need to say make all right, make bind group. Device entry entries self dot binding self dot buffer dot to no dot okay binding dot expect buffer not reading. Okay, render device create bind group. Okay, so that does that, and then we go. So somewhere in the pipeline here, we say oh, wait, what? No, this is creating the pipeline. When we specialize the pipeline, we go, hey, layout. Can we say all right, no, we need auxiliary mesh data, which is just going to be also a bind group layout. Oh well, no, it's a super extract auxiliary mesh bind group layout and a device like that, and then we just need to go, hey, you need to actually store this what? Yep. Right. So you do that, and you do that, and then here we clone that. Right. So that's that all done. We pass that in, and then we go, hey, how do I bind group this? So I need to go to like render, and then we say, hey render, can we make sure that we grab in and also the sroots rendered device. Apparently we could just bind shit ourselves in here. Okay. Let's not do that. Auxiliary. Oh, let's, I guess, get a bind group then. Maybe struct auxiliary bind groups, and then bind group, and do that. We go somewhere, prepare bind group. Okay. Apparently this runs in the prepare bind groups, so let's do it. Okay, I'm gonna say we need that group, which is our res need auxiliary bind group data, and data which is going to be res super auxiliary mesh. Nope. Alright, that was correct. You want a resource apparently, so drive. Just want this to work. And then I've got a bail. So drive resource. Then we go here and we say, hey, can we say that group dot bind group equals as bind group? Render take it away. No method. What do you mean? Okay, fine. As bind group. Thank you. It's got some space. As bind group. Okay, so we're gonna make immutable so that we can overwrite that. Auxiliary bind group, and we say, hey, you need to be an option. Okay, so this will tell us at least if we're getting this somewhere. So entity. Okay, so first off, right. Then we go down here and we say, hey, when you get to here, and say, hey, if let some aux equals aux.bind group, skip. And we say, hey, set you, and then set you to short. Equal straight into inner bind group. Alright, so then that'll bind that to bind, and then we go, hey, like well, first up, you're like rendering a whole bunch of shit in as bind group. So then you equals sum. We should probably also make sure that we initialize this. So app.initialize this. It also means that it needs default. Not default, default. Okay, try that. Then go compare bind group. Okay, we are unwrapping something, but that should be fine because as long as we don't call this before we render the first. Okay, well, apparently we did. Main thread panic buffer not written. Fuck you. Okay. Well, what if instead we said group dot write fine. You do that. You're here. You return an option. Option, and then we shortcut early. Otherwise, we return this sum. Alright, run that. We go, what the fuck is your problem? What do you mean? What are you fucking talking about? Okay, bizarre. As bind group. I think it's still not going to quite work. By pushing that auxiliary data, it's going to crash. Okay, map use can only be combined with the operation. Okay, caused by device create buffer map usage can only be combined with the upside copy required buffer usage read map write. What do you mean map though? How is it a fucking map? It's not a map. Uniform maybe? Has dynamic offset, no. Fragment, yes. So buffer. When I call dot binding, the fuck are you? Yeah, like that, whatever you are. I need to know what your underlying type is. Binding. Buffer. So you're a buffer, yes. What is your problem? Map. In device create buffer. Yeah, but who's doing this? So my suspicion. Yeah, if I never turn it into a bind group, does it crash? Oh god, his nose is horrible. Okay. So, and so it still crashes. So does that mean that when I create it? No, surely not when I create it, because I think it's happening earlier. Handle what? So is it when I create you? Okay, wait, don't use sigil. Raw buffer. Right. Storage. Maybe don't say all. Because apparently it's saying it can't be a map and copy and this and that. So don't just make it all. All is a bad idea. Okay. So, question. The shader doesn't use it, but does it get further? Okay, so create bind group label, use flags, copy destinations to a buffer with label does not contain required usage flags, buffer usage uniform. Right, because I changed it, didn't I? storage. See, I think the reason I need to do that is because I can't have a uniform that's not a... It's probably also going to crash immediately because I don't have the correct thing set up here. What have I got? I just said it is... Well, something's working. Right. Did I include it? I got a storage size U32. So can I say something like... I don't know what I'm doing. Passing in dummy. So if... right, the dummy is the instance ID. So size in dot dummy equals 0. Return black. Oh, doesn't like that. Pipeline fragment is not available in the pipeline layout. What do you mean? Binding is missing from pipeline layout. Group 2 binding, no, group 0, group 3 binding 0. Okay, don't be dumb. Group 3 binding 0. Because I can't stick in the same binding because I can't be bothered adding all the stuff I needed to do that. Okay. There's one black one. One black one. And if I set it to... Okay. You need to put it somewhere where it won't move. And then you go... If I change this to 1, it moves. If I change it back to 0, it goes back 1. Okay. Now, whether they actually assign correctly, I don't know. But in theory, oh, the hell that is this. In theory, we can say something. I gotta wrap up the stream. You got mister. When you do this, can we make an extract resource? Extract struct chunk size, which is a IVEC, no, UVEC size, UVEC, sorry. Let me say if, let me say import extract component for chunk size okay, so what do we need? We need a out is self. No, that's okay. Extract component item. So the item type query data is for is chunk. It's like this. So crate chunk chunk data. I guess T. That's annoying. That's really annoying. God damn it. It is you that has it, doesn't it? Blocks size. Yep. God damn it. Fuck you. Self. You want a component apparently. Derive component. Okay. So query filter type. Query filter. Changed self, maybe? I don't know. Something like that. Then we want to go to you, we want to go to your plugin, your abomination of a plugin. Plugin app. Like app dot add plugin extract component plugin and default. Something like this. Extract plugin. Chunk size. Right, and I need to make you public. And then I need to go to so extract chunk size, we go so chunk size is public, and then we need to go, so I guess it's here, and then map, and then here, and then can we say like include chunk size size, and that's going to be even if flat. So I can't reach it because it's too varied. Solid. So we need to go like lib. We need like use solid color, not material. Use extract chunk size. Lib use okay, we need a pub use home pub use. Come on, just want this to work. Okay, pass in chunk size, and we go back to you and we say voxels chunk size. This chunk size is private. Don't pass in that, pass in splat. Pass in x times pass in yeah, pods equals is pos dot abs dot as vector3. Okay. Struct chunk size is private. No, it's not. Did I not? I've used it there. I've used it here. Need some plating still? No. Okay, so then when we go to our extract, we go here, we go make mesh instance. Make mesh instance map. And we say size is a query for chunk size. Now I do question, because we have this weird thing where you're not actually the right one. So opaque bin key is that value? Okay. Right. No. See, that's the issue. Alright, never mind. Alright, I have to call it a night because I've got other stuff to do. Thank you for tuning in. I will continue working on this another time. But yeah, thank you for coming, watching.